So hello, good morning, welcome. Welcome to today's FME Desktop 2018 training course, upgrading to FME Desktop 28 course. My name is Mark Island. I'm here with Ryan Craig.
Hello.
We just say that for the recording, just to prove that it was us. So what we're going to look at today is all of the things you really need to know when you move up to FME 2018. Because there's a lot of things that change. We don't do this every year, but we like to put on the update course occasionally because things sometimes change so much that if you just went in cold into that upgrade, you'd be like, wow, this is amazing. There's some new stuff, but I don't know what it does or why or how it works. So that's what we're going to be looking at today. We're going to look at some of the key functionality that's changed for 2018 and how it works. And we've got, I'm talking a little bit, but there'll be a lot of exercises as well, a lot of opportunity to do hands-on work, which is really what we're looking for. So what we're going to do is I'll just do a quick overview of the 2018 release and what's new, but I won't go into that in great deal of detail because we've got the deep dive webinar if you want to go back and look at that. We'll look at authoring workflows with the partial run tools, which to me is like the most amazing thing that we've put into 2018.
Absolutely.
Yeah, and Ryan's nodding, and yeah. So, oh, by the way, Ryan, just please do break in and say stuff.
Sit in the corner and be quiet.
Yeah. I think it's always better when there's two of us chatting away. So yeah, we'll look at authoring workflows with partial runs, collapsible bookmarks, which that most of it's fairly obvious, but I'm hoping that there are a few different things in there that should be pretty interesting that you might not have realized. We'll look at precision and tolerance in spatial transformation. We put a new tolerance parameter in a lot of different transformers, and it's worth knowing what that does and why it does it. So we'll have a look at that as well. I might switch the last two chapters around depending on how we're doing for time. The FeatureJoiner, I think, is probably the most important section that we're going to look at out of the two. The FeatureJoiner is a new transformer for bringing data together, a bit like the feature merger, but more SQL based, and we'll see that when we get into that. And the other thing we're going to look at is Microsoft data formats, because we already could read Excel and write Excel, but now we can write to Word, we can write to PowerPoint. We have extra transformers to do that, to handle that data as well. So we're going to do some exercises all around that. So hopefully you can see what I've got on screen. I'm just going to flip through to this section. Oh yeah, on your computer you should find that there's the folder c:/FME data 2018. That's where all the data is, all the workspaces are, a couple of resources that we'll use, and everything should be on there already. So that's all good. So yeah, let's just do a quick look at some of the other things that are new in 2018. So we've got these top tools. I'm going to sort of skip over that because we're going to cover those in more depth. Besides the top things we're going to look at, quite a few interesting things. New formats. We've got a whole bunch of new raster formats, which I haven't really looked at what they are, but they're pretty interesting. I think there's over 50 of them because of the Google technology that we're tied into us. So that gives us a lot of new raster formats this time around. AVF, probably one of the most exciting, maybe not used by everybody, but Apple Venue format for indoor mapping. I think we had version 1 support already, but we've got version 2 now, and so that's something really important for anyone who's doing indoor mapping, is to be able to get their models into the AVF format. Yeah, some few other formats there you can see in the manual. PDF reader is probably one of the big ones. We're not going to cover that today because there's there's a lot of different sort of intricacies around that I've been finding, and I don't think we've really got the time to get into all of those, and not everyone's going to be using it anyway. But I find that yes, you can read content out of a PDF file, whether it's 2D maps or text or raster or whatever. There's quite a lot you can read with that. Click data exchange. I don't know much about that one. Do you know anything?
I've seen a screenshot of it.
Oh, okay.
But beyond that, I haven't seen a whole lot about it yet. But the people who do recognize the name are pretty excited about it.
Yeah, I've seen the name come up quite a lot of times. I don't know anything about it, but yes, you're right. The number of times it keeps coming up is quite incredible. So it must be pretty useful. New transformers, well, I mentioned the Microsoft related ones, and we'll look at those. Besides that, we got a lot of transformers for doing connections to different web services and integrations. So we got a Hadoop connector to read from their file system, S3, Salesforce, ProjectWise, which is the Bentley tool. So yeah, so lots of different connectors there to help integrate FME with these different tools. Workbench updates, these are the big ones that I'm really interested in, the section I'm interested in the most. There's the ability to copy and paste parameters between different transformers. So if I just do a quick demo here, we could say, let's see, what have I got here? I've just opened a workspace at random, and it probably wasn't the best one I could have opened there. But say, for example, I put a tester down, and I put a test in here where, where A equals 5, for example. If I've got another tester anywhere else, what I can do is I can copy that test from here with the copy tool, copy function, and I can paste it into the tester in here, like so. And so I can copy and paste parameters from any transformer to any other, as long as it's the same sort of structure and format of parameter. You're good with that. I think it's most useful for me is going to be with, let's see, what do we do? Conditional updates. So if I've got an attribute manager and I've got it here, and I say I'm creating a new attribute and I'm setting it up with these conditional values, which have been in FME for quite a while now, and I set up, say, 10 conditions, and then I say, oh, actually, I've got another attribute I want to set which has got the same 10 conditions on, or similar. How do I do it? Do I have to make them all over again? Well, now I don't have to. I can just copy and paste that. And I noticed there was a question just come up, can we use Control-C and Control-P? Yes, you can, and you can even use Control-D as well if you're in the same folder. So I can use, oops, what have I done there? Okay, well, maybe that doesn't do the same thing. I'm on a Mac connected to a Windows virtual machine, but you should be able to duplicate a parameter as well as, there we go, duplicate row, Control and D. So yeah, you can use Control-C, Control-X, Control-V, Control-D. And yeah, for conditional values, I think that's going to be immensely important, because the number of times I've had to recreate conditional values again and again. It's not good. Let's see, what else do we have? We have this thing for log filtering. So when I've got the log window open, say I run this translation, we can see how many warnings and errors I get. 5 errors, 44 warnings. Actually, this was a good workspace to show this. So I can click on the errors on the log window now, and it will show me the errors that I've got in there. I can click on the warnings and just see the warnings. I can click on the info and just see the info messages. So we can filter messages in the log window. But again, I don't need to put that in the training course, because you can see those buttons as well as I can, and they're pretty straightforward. Pretty useful as well. Somebody mentioned before that they had a sort of colorblind sort of thing going on, whatever that condition is called, and they said, well, I can't tell warnings from errors because I can't tell the difference between red and blue. Well, now you don't need to. You can just say, hey, these are the errors, and filter the rest out. So that should help anyone who's got a color vision issue going FeatureJoiner has got output ports now, so whatever data goes into the FeatureJoiner, you can actually get it out as well. So you can sort of chain 3 FeatureJoiners together and write the same data out, different formats, do all sorts of things like that. Clothes voids are a new geometry we support, which are sort of a spiral thing that you, or curve that you use for road design, I'm informed. So that's interesting, but probably not to that many people. The other big one we've got is tester date time support. So if I put a tester down and look at the different options, so it's not an operator we're looking at, it's mode. So if we look at the mode, it always used to be automatic and character based, I think. Well, now we've got case sensitive and case insensitive, which I think is an upgrade for 2018, because I can't remember seeing that before. But we've also got date time options as well. So you can say, does A equal B, and it will do a date comparison to see if the 2 dates are equivalent. So that's always going to be a pretty useful thing. And you can do greater than or less than as well. So you can say, is date A greater than date B? And test 2 dates like that. Now, I think they have to be in FME date format, which you can do pretty easily with the date time converter, I believe. So if you've got a date in your own format, you can convert it into FME date format, and then you can use a tester on that. So that's how you would do that. So those are just a few of the things that I wanted to mention in 2018. Oh, we've got some new options as well, right at the bottom of the page there. Tools, FME options, rendering options under appearance. And if you have a display, because sometimes the graphics card and you've got a really high DPI display, it can sometimes affect how FME displays. Very rare, but it can happen. So we put a setting in here that you can check the box if you're having problems with the FME display on your machine. So yeah, use OpenGL for the web view as well. So that basically the start page, if you set that setting, I think it uses a different rendering option there just to make it easier. So yeah, and if you didn't see the webinars, we did the unveiling webinar a while ago and the deep dive webinars for server and desktop. So you can always refer back to that for some of the full list of things. But what we're going to look at now is feature caching. Again, I promise you we're going to get to an exercise soon. It's not going to be me talking all morning. Trust me on that. You don't want that, and I don't want that either. But first, I'm going to talk about what feature caching is. Well, before in FME, you always had that option that's called run with full inspection, and you could turn that on and you could run the workspace, and FME would save the data at every point in the workspace, and you could inspect that data by clicking on it. Well, what we've done now is we've renamed that tool, and it's now called Run with Feature Caching. So let me just, I'm going to actually, let me see, I'm going to open up a workspace. I'm just going to open up something from our basic course just to show you how this works. So we've got a workspace here, and we click Run with Feature Caching. We turn that on, we run the translation, and what happens? Well, what happens is FME saves the data at every step of the translation now. So everywhere you see this little icon, that means that FME has cached that data within there. And we can see those throughout the entire workspace there. So we've saved the data. Okay, so we've saved the data. What good does that do as well? Quite often you want to inspect data at different steps of the translation, and you can do that just by clicking on any one of these caches. So I can say I'd like to see the features that failed that tester. I click that green button, it fires up the data inspector, and here we are with those 7 features that failed to test. So we can do that pretty easily. And you can do that on any of those caches. You can click on the cache and click on any cache you like, and it will inspect that for you. The other thing you can do just to inspect multiple ones is you can right click on the transformer and you can say inspect cached features, and that will inspect everything in the transformer. So we've got the passed and the failed ones in this inspection because I clicked on the tester itself. And also I believe you can select multiple transformers. So you say, well, I'd like to see all of these, please. Right click, inspect cache features, and there we go. We've got the outputs from those 4 cached data sets. So we've got the tester failed and passed, the area calculator, and the logger as well, for what that's worth. So it's not just any one cache. You can actually inspect multiple caches in any workspace. Now, one of the nice things is that we can actually save the workspace with that cached data. You have to save it as a template because there's no way to save it within a workspace file, but a template, if you remember, is sort of a zipped up workspace with data, so we can very easily add it to there. So if you click File, Save as Template, I don't know if you've ever used this before, but a template is basically a workspace with the source data included, and now we've added an option here that says Include Feature Caches. So now I can actually save that with all of this cached data included. And because I've got the cache data included, the next time I open up the workspace, the caches are going to be there automatically, and I don't have to rerun the workspace to get this data. I can just sort of open it up and start inspecting it at all the different steps. So that really makes it very easy. I mean, it's very rare now. I think you'd almost never that you'd need to use an inspector transformer. You could just run with a cache like that. Now, obviously, it's quicker to set up than an inspector, but it does obviously have a bit of an overhead. If you run the translation in caching mode, the translation is going to be a bit slower. It's going to use system resources up like disk space and memory. So you do have a bit of a drawback there, and then it's going to take a little bit longer to run this workspace in caching mode. But at that point, you can just look at all the data at any point that's in there. So that really helps. Plus, as we'll see in a moment, there are other benefits to this caching that apply as well. So we'll have a look at that next. Okay, so the icon that you can see on screen right now is green. Does the green color signify anything? Well, actually, yes, it does. What it signifies is that cache is up to date. In other words, if I ran this translation again, the cache data that will be created is the same that's already cached there. So I know that that cache is up to date. If I change something in the workspace, well, then that cache might not be up to date now. So for example, let's look at this section of workspace. If I change the test in here, say dog park equals no, and I keep doing that, and let's see, park name is not null, basically. So if a park's got a name and it's not a dog park, then it passes. So I've changed the test there. I click OK. As soon as I click OK, you can see that everything to the right of that, what we say downstream of that transformer, everything downstream of that turned yellow because I changed the test. So now what comes out of these area calculator isn't going to be the same because I've changed it. Now upstream of that, everything's still green because nothing's been affected backwards to the left. So we can see now that the yellow caches, I can still inspect them, but they're not going to be the same as what would happen if I ran the workspace. And that's what the yellow color is telling me. Okay, so we've got these caches. Well, what's the point? Is there any other point to the caches? Well, yes, there is, because if you've got cache data like this, we can say, well, if I want to run the workspace again, why am I running these first two steps, reading and doing the attribute management? I already know they work okay, and I've already got the data cached. So therefore, why don't I just run the workspace from that point onwards? And hey, we can do that. If I click on the tester, we've got two pop-up icons here, and one of them says run it from here, and the other one says run it to here. So if I just ran it to here, it would just run everything up to the tester. If I say run it from this, it will run the tester onwards. Where's the tester getting its data from? it's getting it from the cache that's in the previous transformer. So if I click on the run from here on the tester, it'll run, and there we go. And in fact, you can see I made a mess of that test. It should have been and, not or. So I can see straight away I made a mistake. Make a change. Oh, look, the caches have gone back to yellow because I changed that transformer. Run it again. And you can see, I hope, that when I sort of hover over the run button, it highlights what's going to run. So when I say run from this on the tester, FME says, okay, everything in green from this down to the right-hand side is going to be run. And everything on the left, I'm not going to run because it's already up to date. So I hit the run button, and now it runs. And now you can see I've got the results I want, and so on. Same thing here. I can say, oh, statistics calculator. I want to calculate the maximum park size as well. Click OK. Everything to the right of that changes to yellow because, again, it's not the same thing. And I can hit the run button and say run from this on the statistics calculator. And now everything up as far as the area calculator is still green, so it's not going to bother running that again. So you can imagine that's a huge time saver for running big workspaces. Okay, so the other thing I should mention as well is, say I said run the string concatenator onwards. It's like, okay, well, if I look back to where it's getting its data from, the statistics calculator, that's still yellow. And what happens if I run from this? It's going to say, oh, actually, I'm getting my data from the cache that's on the statistics calculator. That's yellow, it's not up to date. So if you want to run the string concatenator, you're going to have to run the statistics calculator as well. So I can say, okay, I should have spotted that. I'll click the run button, and it runs those transformers as necessary. So I can just run little bits of workspace here, depending on what I want to see. If I make changes in the string concatenator, I just need to run that bit of workspace. So we can do things like that. The other thing I should mention is there's a shortcut button, F6. So if I press F5, it'll rerun the entire workspace. But if I do F6, if I click a transformer and press F6, it should just run from that transformer onwards, like so. So I mentioned on Twitter before that F6 is the new F5, and that's what I meant. You've still got F5 there to run the entire workspace, but quite often now you'll be pressing F6 just to run a little bit of the workspace. So I'm going to mention that tip in between, but first I just want to say, why are we reusing the cache data? Well, obviously it's one of performance. If I can run just part of a workspace and not have to run the rest of it, well, obviously that's going to be faster. I don't need to reread the data again. So say my data in here is coming from a database, and I'm pulling out, say, 100 records out of 10 million. Well, obviously I'm sending a query off, I'm using network traffic, I'm hitting that database with a query, I'm waiting for it to come back, I'm sitting looking at my watch, come on database, send me it back. Finally the data comes back, and then we do the workspace. Well, if I cache that data, then I don't need to hit the database again. It's just using the cache data for the rest of the workspace. Now, obviously, if the data in the database changes at some point, my cache is not going to reflect those changes. So I'm going to have to be careful about that. I need to make sure that I'm actually okay using that cache of data and that nothing in the source has changed. But if I do use that cache, it speeds things up enormously. Similar thing with web services. If I put a geocoder transformer down and say, okay, well, this is just they're plain text records, and what I want to do is geocode that data as it comes in. Well, with the caching turned on, I only need to do that once, and then I've got the cached geocoding, and I can just run the workspace from that point onwards. And that's saving time from hitting that web service. Might also save money if I'm being charged per hit on that web service. That I don't need to hit it again and again while I'm running my transformer.
That was one of the advantages of the feature reader transformer, is that it could cache on reading.
Oh,
now
okay.
we've basically added that to every transformer.
Right.
And it's, I guess, when you run this with this setting turned on, it basically overtakes that setting.
I think it does, yeah. I'd forgot that the feature reader had that setting already, but yeah, it's like every transformer's got it now. So the one little bit of advanced thing I wanted to look at was this tip in the manual about when your data is split into two streams in your workspace. Like, for example, I'm just going to run this entire workspace again. Oops. Actually, I don't need the geocoder in there. I guess I'm going to take that out. I'm just going to run the entire workspace again to get me set up. So you'll notice here, okay, let me put another transformer in just for the sake of it, just so I can see what's there. And so now I can say, well, what happens if I want to run this stream of data and this stream of data at the same time? Is there any way I can do that? Well, the only way I can really do that is to go back to the statistics calculator and say run from here, and that'll run from this, and it'll sort of run both of those streams together. But say the statistics calculator, say that was where I got my geocoding, and I didn't want to have to run the geocoder again before I split the data up. Is there any other way I can run both of those streams at the same time without actually going back to the head object and running it from there? Not really, but what I can do is I can put a junction transformer in there. And now I can say, run from the junction. And I'm running from the junction, and I don't have to include the statistics calculator or geocoder or whatever I'm doing, just just to get the data to run those two different streams. So if I've split my data off into separate streams, I want to run multiple streams, but not the head object where they're split. I throw a junction transformer in there, hit the run from there, and then I'll run those two streams, and the junctions just sort of does nothing really. It just holds the data there in the cache. Doesn't do any data processing or anything, so it's quicker. Okay, we got an exercise. I told you we'd have an exercise to do, and here we are. So what I'll do, is there any good questions there, Ryan, that I should mention, or did we cover everything?
We've covered everything, or it would be covering something which we're going to be showing.
Okay,
shortly.
okay. Well, then we won't worry too much about that. So we've got an exercise here. We're going to look at caching. We're going to look at partial runs. We've got a scenario here where we're planning emergency services for the city, and we're going to set up or create a data set of isochrones. Isochrones are contour lines depicting travel time. So we're going to say, we'll take a fire hall, and we're going to calculate how far you can drive from that fire hall in 1 minute, 2 minutes, 3 minutes, 4 minutes, and draw it as a set of contours. That's obviously not the point of the exercise. The point of the exercise here is to show caching and partial runs. So we'll do that. So I'm going to talk through this exercise, but please do carry it out at the same time as I'm doing this. Otherwise, you won't be getting hands-on, and what will be the point of that? So please carry out this exercise at the same time that I'm working on it, and I'll try not to go too fast to make sure that I don't get too far in front of you. And again, any questions, just ping them into the panel, and we can help out. So normally the first thing, like if you've taken training before, you'll notice the first thing I always put in an exercise is inspect the source data. We always say that, inspect the source data before you even go into Workbench. This time I'm not doing that. I'm saying, hey, go into Workbench first of all, and you'll see in a moment why I'm suggesting that. So let's see, I'm going to add a new reader, and it's GML format, and it is going to be the fire halls data. So we can browse to C drive, FME data 2018, which you should be able to find, data, emergency, and the file we want is called fire halls with zones.gml. So I'm going to read that, click OK. It's going to come up with a whole bunch of layers that are in there. The only two layers I want are the fire halls and the medic zones. So fire hall is obviously the location of the fire hall, and the medic zone is the area of coverage for each fire hall in terms of medical emergencies. Now we're going to add all of the roads data. So I'm going to add another reader, add reader. This time it's going to be AutoCAD. Browse to my AutoCAD data set, which comes under transportation, complete roads.dwg, and I'm going to click OK on this. It's going to come up and say, well, these are the layers in here, which do you want? We will use all of the layers apart from layer 0, which is just sort of a header layer. I think we don't really need. There's nothing on it, we don't need it. So I'm going to turn off layer 0, but we'll keep the rest of the roads. And click OK. And move those there. Now the reason I said normally you would inspect data, but here we don't need to, is because at this point I make sure we've got caching turned on. So run with feature caching, and then I just hit the run button and run the workspace. And FME runs that, reads the data, caches it for me, and now what can I do? Well, I can inspect that data. So we've got two advantages there of doing it this way, is that first of all, I can inspect the data like this. I don't need to open it up separately in the inspector, then come back to Workbench and open it again. I can just inspect directly from here. The other thing is, now having done that, the data is already available in the workspace for the rest of the workspace to use. So when we rerun the workspace, we don't have to run the readers again. We've already got the data in there that's cached. And this, to me, just a bit of a tip there, is really a big thing. I can say, well, I'm reading from a data set that's got 10 million records. So what I'm going to do is I'm going to add a reader for that. Then I'm going to hit the run button. And while it's running and reading that data, I'm going to start adding the transformers I want to manage that data. By the time I've finished adding my transformers, FME will have read and cached the data, and I can just carry on testing my workspace like as to continue. So yeah, so put your reader down, hit the run button straight away. That's what I'm going to suggest we can do now in 2018. And we can inspect this data here. I can say select the roads, right click, inspect. I can select everything, in fact, right click and inspect. And then I get everything in there, all of my roads, my fire halls, my zones, and so on. So if I want to inspect the data, that's the way to do it, I think. So if you do that, you run that, you inspect the data, you'll find that we've got a set of roads, we've got a whole bunch of points for fire halls, and we've got some different medic zones. And you can see we've got 8 fire halls and 5 medic zones just from the feature counts. So that's useful in itself. Now what we're going to do is we're going to work on a single fire hall number 4. So what I'm going to do is I'm going to attach this tester to the fire halls. And just give me a second. I'm just going to make sure I do have, yeah, I've still got web connection because I can connect to things. So I just wanted to test out. I don't want to be talking to myself. So, okay, so I put a tester down and I'm going to open up that tester and I'm going to set the test value as name. The test is ends with, and I'm going to put the number 4. So if the fire hall name ends with the number 4, then it passes the test. So what can I do now? Well, I can go to that tester and run from here, run to here. It'll give me the same thing in each case, or press F6, and it'll run that tester with the fire hall data cached, and I don't have to reread that source data. It seems to be taking a while to do that. No, nothing's got messed up. That's taking way longer than it should. Let me just stop that. Try that again. Okay, that is very interesting. It's one of those things where something just, I don't know why it's doing that. I got to say, it shouldn't be taking more than a second to run that translation. Well, let me stop that and try and run the whole thing. Maybe the test just got something odd in it that I hadn't noticed before. Okay. That is very interesting. Any thoughts on that, Ryan? I'm
still starting the translation.
Yeah, maybe
something's derailed, that's for sure.
Yeah, I just wonder if maybe I've suddenly become unlicensed, but I don't think so.
Looks good.
Yeah. Okay, well, what I'm going to do is I'm going to shut down Workbench and start that up again. Now, hopefully it's working for everybody else.
You also close your data inspector. You might be running low on memory.
Okay, that could be.
So we've been inspecting a lot of things.
Yeah, I didn't think I'd been inspecting that much, but
it's working for everybody else.
Yeah, Task Manager, 40% of memory. That doesn't seem to be that excessive. Okay, so it must just be something I've done there, I suspect. So I'm going to
audience detection checkbox. You gotta turn that off.
Do you want to stop the translation quick Workbench? Yes, I do. We're going to fire that up again, and hopefully it works better this time. This is like a number of times I've done that. And then, of course, the one time we do it in an exercise, in a live demonstration, and it fails, that's just, it really does not like Workbench. What if I have become unlicensed? Okay, so what I'm going to do here is I'm going to bring up Workbench from the MacBook that I'm working with. And I'm going to run it on there. I guess I don't need to have that going on. Okay, so hopefully you can still see my screen. And what I'm going to do is going to add those readers back in. Okay, well, while I'm doing this, you can perhaps carry on doing that exercise. What we're on, complete roads. Click OK. Don't need 0. That's okay there. So it might look a little bit different because I'm working on a Mac on this, but that's okay. And the other one was GML, wasn't it? It was GML, and it came under emergencies, files with zones. Okay. And we wanted the medic zone and the fireholes. Okay, so we're good with that. So I'm going to find it difficult here to show both. Oh, actually, I should run at this point, shouldn't I? So turn on full inspection and run. And I'm going to put the tester down. And I'm going to put that on the firehole. And we'll throw that tester in there, and it was going to be name ends with number 4, and click OK, and that's good. I need to just open up my web browser so I can actually see the instructions, and we're going to do this. Just give me a second, we're nearly there. Oops, wrong way, here we go. And here we are. And so feature caching, we're on exercise 1. Oops. Emergency response. Okay, here we go. So I've done up to step 4, we've added the tester. And, oh yeah, forgot that. We can run that now, and the test comes up, and I can see the one feature that passed, and I'm good. Like you see, 0.4 per second. So something was going on that machine, that's for sure. Okay, so network cost calculator, we're going to add that. Now, what I want to do with that is to add that and connect all of the roads into the line port. I don't want to have to do them separately. So what I'm going to do, and this isn't new to 2018, this has always been there. I just don't know if everybody knows about this trick. I select, excuse me, all of the objects I want to connect to that transformer, and then I use quick add to place that transformer, and everything that I had selected is automatically connected in. So now I don't have to make all those individual connections to that line port. So if you weren't aware of that little handy tip, it's certainly worth being aware of it. So we've got the tester connected as well. So the tester is the source and the network cost calculator is there. And you can see I've got the numbers on those connections. Even though I haven't run it yet, we've got grayed out numbers there to show how many features would pass through when it runs. So I'm going to hit the, oh no, I need to check the parameters. Wait times by length. We're going to output everything as a Z value, and we're going to snap. So in other words, if the firehole doesn't sit on my road network exactly, it'll snap to that road network as long as it's within 100 meters. So now we're going to run that translation, and again, I'm going to use run from here on the network cost calculator. You can see by hovering, in fact, I can use run from this or run to this. It doesn't really make any difference in this case. Okay, so there we go. I can inspect that data. I'm just firing up the data inspector here. I'll drag it. Oops. So I'll be there in a second. It's a problem with having two monitors. There we go. So we've got the roads. If I zoom into that, start querying some of these data features, I can see that these roads have got Z values now. So this road goes from 127Z to 299Z. Now that obviously isn't an actual elevation. What that is that's the actual distance from my firehole. So in other words, that first point is 127 meters from the firehole, the end point is 299. On that link, the first point is 299, the next point is 473. So what we've done there is calculated the cost from my start point to get to that point on the network. That's what the network cost calculator does. So now what we can do is we can actually create some contours. And I'm going to put the contour generator down and connect it to the connected output from the network cost calculator. I'm going to look at the settings for it. Surface tolerance to 10, contour interval of 50, and I think we'll click OK and run that, and we should be good. Now, we did notice over the last couple of days we were trying this out, we seem to get different results for a couple of different people. So if yours doesn't look exactly the same as the manual, don't worry too much. That's something I'm going to look into. I think there's a point around here, if you can see, that I think has got a problem. In fact, I know there's a problem, and I know what the problem is, and I'll show you that later. But for now, we can see that my original point is there. That's 50 meters away, 100 meters, 150 meters, 200 meters, 250 meters, and so on. So we've got now a set of contours showing us the distance from the firehole to certain points on the road network. Now that was distance, that wasn't time. We wanted to do time. So just make sure I've got that on screen. So how do we do time? Well, we need to set an expression to turn distance into time. What I'm going to do is put an expression evaluator in. Another quick tip, again, not 2018, but you might not be aware of it. If I want to put an expression evaluator in here, if I just select one of those connections and type that in, it only gets put into one of those connections. If I wanted to go in all of the connections, what I do is I click on the green arrow on the network cost calculator where all of the connections come in, and that basically says this is where you're going to insert your transformer. And so it connects it all up automatically for me. Notice all of the caches downstream of that turn yellow because now they're not going to be the same as what we had before. So I set up the expression evaluator by saying, let's create an attribute called travel time. And the expression is at length, which we could find as a feature function on this menu if we really wanted to. Oh, sorry, at length, not multiply length. At length multiplied by 916.666666. Now, where did we get that number from? Well, that comes from speed, which I looked up and found that the average speed of an emergency vehicle in a city is 55 kilometers an hour. So it's the speed, meters per second divided by seconds per minute. 55 times 1,000 divided by 60 gives us 916. That's where that number comes from. So we click OK. So we've calculated the time. Now we actually need to adjust the network cost calculator to take account of that instead of distance. And we just do that by saying use attributes, and it's going to be travel time. It's going to be our weighting. So it's going to add a weight to the distance of the travel time. And then finally, we're going to contour generator, because instead of saying 50 meter contours, we're going to say we want 1 minute contours. And we'll set the surface tolerance to 1 as well. And we click OK. So now at this point, we want to run the translation. And again, remember, this is all about using partial runs and figuring how we do that. So what we can do is we can say, run from this on the expression evaluator. So we could do that. So that will be run from this on the expression evaluator. You can see what highlights there. We could run to this on the contour generator. We get the same highlights. Or we could actually use run from this on the contour generator, because that's all we really want, is the contour thing to run. But if we do that, FME is going to say, oh, you can't do that unless these other objects are also run. So that's fine. We'll just do that. And there we go. So we should be looking at some new output in a second, which will be a series of lines representing travel times for emergency vehicles from fire hall number 4. And it should just take a second. Obviously, the network cost. By the way, you can see a little animation going on screen while the cache is updating. If I hover over that, it tells me how many features are in that cache. So that tells us that things are still going on. Contours being output. Oh, it's just shouldn't be running this slow again. Let's. I do seem to be having not a lot of luck this morning. Okay, I can't be running out of memory on all of my machines, so I'm hoping it's working for you folks. Again, what you should do once you've got that working is you can click File, Save as Template. Oops. File, Save as Template, and when you save the template, include the feature caches, and they will be there next time when we open up that template. So hopefully everyone's got through that exercise okay. Hopefully you got through it better than I did. Again, typical running in a live scenario and everything starts to go wrong. So hopefully that's not too much of a problem for us. Okay, I'm going to stop that because I don't need it running. You've seen the whole point of that exercise, so it shouldn't be an issue. Let me just make sure I'm not running a whole bunch of stuff that I don't need to be running. Just to make sure it's not a memory error or something like that. I'm just shutting down everything I can think of, like, yeah, I don't think I need iTunes running. So just in case it's my machine having a bit of a brain meltdown. Okay, so what we're going to look at next is bookmarks, and in fact, this new function for FME 2018 called Collapsible Bookmarks. So a bookmark, well, we know already it's like a real life namesake. It's a means of putting a marker down. It lets us access a particular area of a workspace quicker. So I can say, let's open up a translation here. FME data workspaces. Just open up a basic one from the basic course. And hey, we've got bookmarks around that. And you can see that bookmarks are really just a way of dividing that workspace up into pieces. And you'll notice that you can put one bookmark inside of another. I don't have that here, but I certainly could do. And in 2018, we have this idea of taking this one step further with collapsible bookmarks. The bookmarks in 2018 have this little icon in the top left corner, which I can collapse. I can click on that and it'll go zoom, and it will zoom like that. That's the official terminology we're using there, zoom, and it compresses everything that was in that bookmark down to just that one particular, just that one small object like that. So even if I've got multiple transformers in this workspace, I'm just going to throw an extra transformer in just to demonstrate. Even if I've got that, I can collapse that and make it into a small bookmark like so. And I can collapse all of these objects like that. And basically it saves me space on my canvas. I'm not having to see all of the contents for that workspace. I can just collapse a bookmark and see part of it. Now, that's not particularly something I need to teach about. You can see that button there, you can click it, you can figure out what that does. There are some other things though that we need to talk about, like how does it compare to a custom transformer? Well, it compares to a custom transformer in that it compresses the amount of space needed. So like I had that space, I compressed it down into a smaller area. That's pretty much what a custom transformer would do as well. But you can't copy that as easy. A custom transformer has a central definition, and editing that definition updates all of the custom transformers. We can't do that with a bookmark. Even if we say copy that bookmark and paste it somewhere like that, it'll have the same contents, but it won't be connected to a master thing anywhere. For example, if I change this transformer to calculate something different, it won't apply to the other bookmark as well. It won't be in there as well. Whatever you change only applies to one bookmark. So that's one of the ways that a custom transformer has got an added benefit. Delete that, that's gone. The other thing it won't do is publish parameters. Custom transformer lets you set publish parameters inside of it. We don't do that yet, but I suggested it to our developers and they said, oh yeah, that's a good idea. So hopefully before too long, you'll be able to click on this button there and it will come up with the list of published parameters as well, and you can set the values in there. But for now, we don't do that. But I'm hoping in the not too distant future. So anything else we need to know about these bookmarks? Well, one of the things is you've got the little parameters button now in the top right. We can click on that, open things up. That'll let us set the name and the color. We don't have a description anymore, but what we can do is we can attach annotation to a bookmark. So we figured that you probably didn't need to have a bookmark description as well. You could just use annotation. The input and output ports, we can rename those on a bookmark. So for example, here it's got area calculator because that's the transformer it's connected to coming in. What I can do is I can double click this port and say parks to have area calculated or something like that. And on the output, I can say parks with stats. So I can rename the input output ports on an object like that. How do I do that? Well, I can double click it, I can right click it and choose rename, or I can click on it and press F2. Any of those ways will let you rename that port on a collapsed bookmark. Now, why would you want to do that? Well, because really it's for clarity. It's knowing what is supposed to coming into the bookmark and out of it without actually having to expand it and see what it's connected to. So it's a clarity issue there. The other thing is rearranging the bookmark. So just an example there in a manual, you could say, hey, let's go to the bookmarks on the navigator window and collapse all of them at once. And that saves a ton of space. What am I going to do with that space? Well, obviously, I'm going to move the bookmarks closer together, like so. I'm going to move them so they're close to each other, like this. I'm going to delete that annotation. I don't really need it. So we can move all of these bookmarks that have been collapsed over here and make this a little tidier. Now, that's great. It makes it tidy. The other good thing it does is when I open and close this bookmark, FME will move the data about rather than it will move the objects about rather than just trying to overlap them. So, for example, if I open up this bookmark, we should see that, okay, anything underneath it is going to get moved away. So move stuff away, collapse it again, it moves back. So opening and closing the bookmark should move objects with it. So you can compress your whole workspace down to this and then open bits individually and say, oh yeah, I'll make a change there, put it back, and there we go. So we can move bookmarks together into that area, and FME will open and close things and move stuff around to match and then put it back again. Now it won't do that if I say move this bookmark away like that, then collapse this one. Oh, actually it worked there. Like if you move it too far away, I don't think it'll come back when you collapse it. I appear to be wrong, but there you go. I've had that before where I've moved some things or edited some things and it's not come back in the same way, but it should do, and it seems to do now. And if I have multiple ones open and then collapse, say that first one, that's okay. There you go, like that. Now if I collapse this, okay, we've got that. So it's not perfect, but generally it should be pretty good with moving things back to where they were before. Okay, so that might not have been obvious. The other thing that might not be obvious is how this interacts with partial runs and caching of data. And it does very much affect that, and it has been integrated very well together. So the first thing we can see on here is that I can do a run from or run to on a bookmark. It's got the same run buttons that transformers have. So I could say, let's run and run this writer feature type. And again, it'll tell me if data is missing. Let's see, data, parks. It'll tell me if I need to run prior aspects of that workspace, because I don't think I've run it at all yet. So let's run it. And yeah, so it's got the same run buttons as well. Now, the other thing is when bookmarks are collapsed versus when they are expanded. So if I run this workspace with my bookmarks expanded, you can see that every different transformer gets the data cached within it. If I run it when it's collapsed, that doesn't happen. It only caches the data on the output transformers. So if I collapse these and run this workspace again, it will only cache data on the areas that are on the output. So there we only get that one there. We don't get that other transformers don't get their cached data there. Why do we do that? Well, that means that you can, because quite often you might have a huge workspace and you just want to run part of it, and you say, well, I don't really need to cache the data for that bit because I know it works okay. So by having that collapsed, you're not caching all of that data in there unnecessarily. Okay, so exercise time. Let's So I'm going to go back to that workspace I had before. So this is where we find where templates are useful, because I could say, well, let's pick out the template for this exercise, and it'll open up, and everything was still cached because I had caching saved with the data. So did I make a mistake on that previous one? Should it be? Yes, it should be divide, not multiply, shouldn't it? Eesh. No wonder everyone was getting a mess. Probably that's why it took so long to run on my workspace. It should be divide and not multiply. So yeah, that was my mistake there. Whoops, sorry. Yeah, so length divided by 916, not length multiplied by 916. Yeah, that would have caused a big slowdown there. That's why you always read the manual. Okay, so we've got our workspace here from the previous exercise. And again, if you didn't get it running last time because you messed up like I did, you can just do what I did there and open up the cache for this workspace, and it has got the cache. Open up the template for this workspace, and it's already got the caches there already. Okay, so what are we going to do? Well, first thing we're going to do is add a bookmark to make the canvas tidier. So I'm going to put a bookmark around my road features, like so, and I'm going to call it AutoCAD Roads. And I could collapse that now. But if I collapse it, well, I'm still getting a separate output for every object there, and I don't really need that. Like really, I only need one output because the data is all getting merged together anyway. So what I'm going to do is I'm going to do another trick with the junction transformer, and I'm going to put that junction in here, like so. And then I'm going to expand the transformer to cover that, and then I'm going to collapse it. And now we only get a single thing, and it's a junction output. I'm just going to rename that to roads. So by adding the junction in there, it meant that I didn't have lots of different output ports I didn't need. So that's one bookmark. To go back to the task that we're working on, we got contours that cover the entire city. We didn't really need that. We only needed contours for the area that firehole number 4 covers. So what we're going to do is put a clipper down and clip everything that we created to that area. So I put a clipper down. I guess it would almost make sense, because in the manual it says connect it after the custom contour generator. It would almost make sense to clip it beforehand, but I'm not going to do that. I'm going to follow the instructions in the manual this time. Okay, so the medic zone is the clipper, and the rest is the clippy. Oh, we need the tester as well, because we don't want multiple zones. We want just that one test. So here I'm going to duplicate the tester transformer. Now I could, of course, put a new tester transformer and just copied the test over from this transformer to the other one. But since it's inside entirely the same test, I'm just going to duplicate the transformer completely. So we'll duplicate that transformer, and that becomes the clipper, and the contours become the clippy. And you can see that some of these don't have a cache at all. Like there's no green or yellow cache because I've just put them down, so there's no cache on those objects. Now don't run the workspace yet, because let's see, we have these objects here, and we don't need, if we run the workspace again, these are all going to get new caches generated, and I don't really need that. I mean, they need to be run, but they don't need to be cached, because I know that part works. So what I'm going to do, select those objects, put a bookmark around it. I'm just going to call it processing because it's quicker to type that. And I'm going to collapse that bookmark and then just rearrange everything around that like so. We don't like overlapping connections, so I'm going to do this, and there we go. So now if we run the workspace, if I pick the clipper and say run to this, it'll run everything, but it won't cache everything inside that bookmark. And we can prove that by opening that bookmark up and saying, oh look, the contour generator's got a cache, those two don't. The tester has got a cache, and I'm suspecting that's because it already had a cache that was up to date. So FME said, oh, well, you've already got that data cached, we might as well just keep it cached. So I'm guessing that's why that still has a cache there. But other than that, only the contour generator got a cache this time around. And if we look at the output now in the clipper inside, we should find that we have contours that have been clipped to the area for firehouse number 4. In fact, what I could do is pick the clipper. Let's see, what else can we do? I could, oh, I want to, yeah, I'll pick the tester as well and inspect both of those. So I can see that it has clipped. So I'm going to kill the clipper outside and hide the background. And there you go. We can see that we do actually have contours clipped to that boundary. So now we can say, hey, this is where the fire hall is, in the middle of there, and this is where it can travel to within a minute or 2 minutes or 3 minutes, depending on traffic, obviously, but we're not taking account of that yet. So there we go, that's it. And really we were trying to show bookmarks there. There's not really a lot we could do with bookmarks apart from show how it doesn't cache data. So that was really one of the key things we're looking at there. Okay, so I think what we'll do is we'll talk about precision for a bit, and then perhaps we'll take a break because it'll have been an hour and a bit then. So we'll talk about precision, then we'll take a break and sort of do the exercise as well at the same time maybe. But for now, we'll talk about precision quickly. So everyone up to speed with that exercises? I'm hoping we're all up to date. Yeah, it runs. Yeah, sorry about the expression evaluator. That was totally my fault. I think it's because one workbench failed, then the other workbench failed, and I was in a bit of a panic and ended up typing the wrong thing. So apologies for that. That's why I was doing that. So anyway, if you got that working, it should look something like that. And if you're interested in that exercise, by the way, and how it works and the isochrone idea, there is a full tutorial on our website, on our knowledge base that covers that thing with a video and all sorts of things. But it has some other ideas as well about what you might do with those ISO lines. Like you could set up arterial roads to have a different speed to residential roads, that sort of thing. There's another example where the blocks are color-coded. If we can look at the output from this is another example. I really like that one. It's sort of like a heat map of how far you can travel in a certain time. So you can do all sorts of things with this once you've got the basic technique down pat. So I just wanted to show that because I really like that idea. Okay, let's carry on with the tolerance. Okay, so in 2018, we introduced a tolerance parameter to many transformers. Just going back to this workspace for a sec. For example, the clipper is one of those. We look in the clipper, there is a tolerance option under vector parameters that never used to be there. And it could be none, automatic, or custom. And we added that to quite a lot of different transformers. Why those transformers? Well, it's because we looked at a particular piece of code that was used in lots of places, and we said, can we improve that? And it turned out we could. So wherever that piece of code got used in any transformer, we can expose that tolerance parameter. And so we have line on line overlayers, low, and that one has a tolerance option as well. And the line on area overlay, LOAO, that one has it. The generalizer, the intersector, that's got it as well. So there's a lot of these transformers have this tolerance option. And we used to have a transformer called a sliver remover. We replaced that with a new transformer called the area gap and overlap cleaner, and that's got the tolerance option as well. So what do those settings mean? Well, if you've got the tolerance set to none, basically it means it'll work as it did before. There'll be no tolerance applied. So if two lines, you're trying to intersect two lines and they don't intersect by a teeny tiny amount, then they won't intersect. We're going to take absolute values for the coordinates, and that's going to be applied to whatever action we're carrying out, whether it's intersection or clipping or whatever. Automatic means FME is going to decide a tolerance for you. And what that's trying to do is try to resolve minor issues with coordinates, like coordinate precision, coordinate rounding, that sort of thing. We're trying to sort of resolve the teeny tiny little problems that you probably don't even realize are there and fix those issues. And that sometimes those issues happen because of our processing. So if we do a dissolver, sometimes we can dissolve data and leave little slivers behind because of the dissolve algorithm. Well, this automatic tolerance will clean that up completely. So that is what the automatic will do. It will try and clean up teeny tiny little issues in the data. And a custom value basically means you're going to enter a tolerance. So we could say, hey, I'm going to enter a tolerance here of 0.5, and anything that's within 0.5 of a meter of each other, that'll get intersected in that process. The other thing to mention is some of these transformers have got a collapsed output port. That's for when you've got features whose size is smaller than tolerance value and collapse down to a single point. So say I've set my tolerance to 1 and I've got a line feature that's got 2 points, 0.9 of a meter apart. They'll probably get collapsed down together because their tolerance is smaller than, their distance is smaller than the tolerance. They'll get collapsed down and they'll be output from the collapsed output port. So if you see a collapsed port, that's what that does. I should mention performance. The techniques we're using in this new functionality is better than before. And so you might find that using automatic mode is actually faster than using no tolerance at all. So that's something just to be aware of. In many cases, it will be faster. Now, what are the things can tolerance fix? Well, in general, when you've got data that doesn't meet, and I hope you can see in the manual here on this page, I've got 2 examples there of problems. And the first problem is the data is just created badly. I've got 2 lines that should connect and they don't. There's a gap of 10 meters. 10, okay, 10's really extreme, I guess. Might just be a meter, might be 0.1 of a meter, something like that. That's the sort of thing FME is not going to be able to fix automatically. The 2 lines are meant to connect, they don't connect. There's basically been a data creation problem. The other issue you might get is where 2 lines don't connect, but the gap between them is very, very small. Like in this second example, I've got 2 lines that should join up together, 2 road features, and there's a gap between them of 0.000000001 of a meter. Like, I don't know, that's like a nanomillimeter or something. So obviously those lines are meant to connect, but there's this very small gap. And it's very difficult to locate that visually because of that small size. You could look at the data and it would seem to be okay, but it would only be where you zoomed in very close that you would actually see that gap. So how does this tolerance fix those problems? Well, in that case where you've got very, very small data, like a nanomillimeter between them, if you say no tolerance at all, then FME says, okay, those 2 don't meet. They're like a nanomillimeter apart, but that's still a nanometer apart. They're still not exactly the same. So therefore, these 2 features do not meet. So if I was creating topology in a road network, and 2 roads didn't join up by that amount, with no tolerance, FME would say, okay, obviously they're individual roads, they don't meet up, therefore we're going to put a node on the end of each of them. So it probably wouldn't be the correct result in that example. That's not what we really want to do. Now, when the tolerance is automatic, FME assesses the data and comes up with a reasonable tolerance to try and solve that sort of problem. So for it would say, well, hey, 1 micro nanomillimeter is not really a good tolerance, a good gap for data. It probably is just a rounding thing or a coordinate thing. We'll automatically clean that up and make sure the data fits together. So it will join those two roads together and put a single node down. However, what it's not going to do is it's not going to try and fix the gross errors that you had the difference between, like we said, oh, there was a 10 meter or 1 meter gap between that. FME is not going to go searching for 1 meter gaps to try and close them off. That would be ridiculous. You might realize that's a problem, but FME is not going to be able to know that. So it won't fix gaps like that automatically. It's only going to fix things that are like fractions of a millimeter. That's what it's trying to clear up there. And that sort of thing can happen when you're pulling in data from different formats. I guess many GIS packages don't have this issue because they all use sort of their own format of data, and that's not a problem. But in FME, we could say pull in some map info data and some AutoCAD data, and it might be an exact copy of the two data sets, but it doesn't quite match because they store coordinates in a different way. So like, I know AutoCAD stores it as a floating point, and MapInfo stores it as an integer, or the other way around, and it just doesn't match because of that. There's a rounding issue going on there. So that can happen with multiple formats. So what's the custom tolerance for? The custom tolerance is when you do want to try and fix those gross errors, like the 1 meter gap, the 10 meter gap. If I put a tolerance of 10 in, well, it might fix that node, but it might also cause other nodes to collapse on themselves because they're closer than 10. So when you're working with custom tolerance, you have to be a bit aware of what exactly is going on and what the effects might be on your data. And I'm sure you know that already, because I'm very wary about putting my data through automatic processes like that, just to fix one problem and find out I've created 10 more of them. So custom tolerance works, but of course it's up to you to make sure that your tolerance is correct for the data you're using. Now, one example I wanted to show was actually this one with the medic zones and so on. Now, I'm just going to run this again because I want the caches this time. And hopefully it shouldn't take as long because I've got it set up correctly this time. So if I look at the contours, they look a little bit off there, a little bit odd. Let's look at the network cost calculator. Actually, yeah, let's look at the output from that. See, if I zoom into this area, I think I found this the other day that, where are we? We're on Birch Street and West 7th, I think it was. If I query, well, actually, if I zoom right into this, I'm zooming way into this, like, oh, look, that doesn't actually meet. Those two lines don't meet. I hope you can see that on your screen. But I've got lines there that don't meet. This line coming in from the right really should be noded with this one here. And the difference in distance between them is 0.0059 of a meter. So it's, let's see, so it'll be 1 meter, 10 centimeter, 1 centimeter, 5 millimeter gap, I guess, or half a millimeter gap, depending on how my math is there. So that's a very small gap. And obviously what should have happened is that road should have been noded onto this, because you don't get roads that are 0.5 of a millimeter apart. So obviously that node was wrong, and worse still, if I query this road, you'll see that it just cuts straight through there. So the time is half a minute for that, 0.6 of a minute for the other end, but this one is 0.9 of a minute to get to there. That's because to get to that node, you've got to come across and all the way around the block to get to that, because it doesn't connect properly. So we can see we've got a problem there with a very tiny mistake. So that's one of the things I can do and fix with my intersector. I can say, let's intersect that data. Let's intersect it right at the start just to make sure. I can intersect that data. I can say, set the tolerance to automatic. And now, when I run this translation, what we should find is that we've automatically fixed that problem. You don't need to do this exercise as well. It's just something I realized because I was looking at the contours thinking, they look really weird contours. There must be something going on that's not quite right. And yes, it was this that was the problem. So now if I zoom into this, we should find, even though there's that slight offset, we've intersected the data like so. So hopefully you can see that on your screen. It's probably very difficult to see, but there it is. And now, so the end point of that is no longer 9.9 of a minute away, it's 0.5 of a minute because we can get to it through the proper network. So that's an example of where the automatic thing has solved one problem for us. So now the contours will look a lot better around that point. Of course, as soon as I did that, I noticed that there was another one that had the same problem. The one on the street next to it, this data really did have some problems to it. And unfortunately, that did not get fixed. If I zoom into that and measure the distance, it's a little bit more of a gap. Basically, I guess FME thought, well, that's too big of a gap to fix. I shouldn't fix that one. So, okay, well, what am I going to do to fix that? Well, I'm going to go back to my workspace. I'm going to set the intersector with a custom value of 0.1, which 0.1 is like 10 centimeters. That's really nothing. I'm going to run that again. And this time it should, well, I know it will because I tried it earlier, it will actually give me the right result in that data. So that's the sort of thing. That was just sort of happy coincidence that I found that. I wanted to find out what the issues were with that data, and then I sort of looked at it and thought, intersection and tolerance. So we have this tolerance setting now, and it will basically sort those out so they all meet and are all noded correctly. So just wanted to show you that in that example there. Okay, so we've got another exercise to do. I've been talking about, well, we've been working for an hour and a half now. So what I'm going to suggest is we take a 10-minute break, grab a coffee, bathroom break, whatever. But at the same time, if you can start working on this exercise, that would be good. And then I'll come back after 10 minutes time and I'll run through it myself. So yeah, so have a go at tolerance and data cleaning. And I'll just tell you, this one came about because I created this workspace part of a tutorial in FME 2017 and it seemed to work pretty good, I thought, but then a developer who did the tolerance stuff found this exercise and said, oh, you can just replace this now with this one transformer and it'll do it all. So okay, well, thank you. That's just ruined my tutorial, but that's fine. That's good. Obviously, it's good for the users, even if it means I've got to go back and do that again. So anyway, so what we're going to do here is we're going to open up this workspace. In fact, it's actually a template that we're opening up. We're opening up a template just so we got a copy of the data in there. Also, it's got caches probably. Actually, I don't think it does have caches because I haven't run it yet. Now, what are we doing? Tolerance exercise 1 begin. So we're going to open that up. Yeah, there's no caches because I hadn't run it, but it does have a set of data included in it, which wasn't in the data set. So that helped us get around that. Okay, so what we've got here is we've got a reader, a parcel data, and we've got this workspace that I put together for cleaning up data in FME 2017. What we want to do is we want to build area features out of this data. So I'm just going to run the workspace to get the parcel lines there and just inspect that data. So what we've got is a set of features, and these are all line features. They're not polygons. The whole point of the exercise is that we turn them into polygons. And you would hope that the data is clean and creates properly formed polygons. But I think if you were hoping that, you would be hoping in vain. I don't think that's exactly what we get. But we can prove that by putting an area builder transformer down and basically just running it from there. I don't think we need to do any settings. So what do we get out? Well, we got 71 areas and 8 incomplete features. If I inspect that data, let's fill in the areas with a fill color just to give them, oh, there we go. We'll go for a pink color, why not? Okay, so looks like we got areas, but if we look at what the incomplete features are, oops, it's a bit too wide, but we'll make them a dark blue. Okay, so we got some incomplete features there. Now, if I zoom into that, you'll find that that area actually ignored the line down the middle and just sort of overlapped it. So those polygons are not correct because they ignored the lines in the middle that weren't properly cleaned. So we can see that there are definite issues with that data set. Okay, so how are we going to fix that? Well, in 2017, we had this workspace that I put on our knowledge center. So let's connect that up into there. I'm going to go to the end here. I'm going to get rid of those 2 inspectors because we don't need inspectors anymore. We know that. Actually, I need to see where they came from. Intersected and complete. Okay, so I'm going to pop down an area builder and send the data in from there and from here and run that translation up to that point. Am I doing that right? I should read the, yeah. So let's have a look at that. Well, we've got 94 areas, which seems to be more than we had before. I mean, querying the areas looks okay. So we've sort of got the areas we wanted. That's better. The one thing I did notice was that we seem to have little teeny tiny little areas up here where there was sort of an overlap. So it wasn't a perfect method, but it's still, as a method you put together in as sort of a custom transformer, it seemed to work pretty well. We got a good result out of that. So I mean, it does work, that method, but I mean, if you're a user in FME, you shouldn't really be expected to come up with a whole thing like that just to clean up your data so you can build areas out of it. It must be a better way. And in 2018, with this new tolerance setting, we've got exactly that. So let's pick this bookmark, right-click on it, select all objects in bookmark. Oh, in fact, the better way to delete it, I've suddenly realized, is you can just collapse it and then delete the bookmark. And that takes out everything that was with it. So that's the better way I found to delete a bookmark and everything in it. Because before you would have to say right-click, select all the objects in the bookmark, delete them separately, and delete the bookmark. Whereas if it's collapsed, you can just delete the bookmark and everything's gone. So that's another bit of a tip there. Okay, so we got rid of that. Let's just put down an intersector transformer. So we put an intersector down there, like that, and rerun the translation. We're going to use automatic. So we're going to run that, and we are going to inspect the output. So now, did we get any improvements? Well, actually, I think we did. We got some improvements there. It'd be nice if it filled that in, but there we go. So we got some improvements, like most of it seems to be okay, but then that one looks wrong. There should be that should be 2 polygons. So some of it worked, like that used to be 1 polygon, and now that's been fixed. So some bits have been fixed, some bits haven't. So in other words, whatever my problem with my data was, it's a bit more than FME really wants to commit to fixing by itself. It says, well, some of these look like they're down to coordinate rounding. There's some that could be some other issues, and you might want to check that out. So let's do that. Let's go back to the intersector. Oh, see, I didn't even have tolerance set. Well, that wasn't very smart, was it? So it couldn't have been better. I must have been seeing things there. If I ran it in automatic anyway, yes, it would have some better results. But the other thing we can look at is custom value. And if I set that to 0.2 and rerun that, yep. Then look at this data. We can see I've only got 77 areas now, so things are looking better already. The incomplete features, let's just increase their width so we can see, okay, so there's still a few about, but not so many. And these ones here, they look like they're unused because they are, what do you call it, overshoots. We've just sort of cut off those overshoots, and that's an unwanted piece of data there. So, so that's all good. So it looks better, but it's not perfect. And again, if we go back into the area builder, oh, sorry, not the area builder, the intersector, we can change the tolerance again to 0.3, which is probably still okay for this sort of data. Run this again, and now we should find that we have the right number of area features, and any information that's incomplete should only be little overshoots that just aren't being used. They don't form an area. So we've got all of our data looks correct now. So what I've been finding as I've been using this is that sometimes you can clean up some of the issues with the automatic tolerance. Sometimes you need to go in and set a tolerance parameter, whether it's a small or a larger one. Anyway, sometimes I'm finding that. I think for me, in this data, 0.3 is okay, because really you've got no lines that are that short, so nothing's going to collapse on itself or anything like that. But anyway, so we've got the same results as that entire bookmark of things did in 2017, and we've got fewer sort of artificial oddities and artifacts on there. So it really is a big improvement in cleaning data now. So anytime I'm building areas, I'm certainly going to put an intersector down before it and say intersect it with automatic mode at least, and see what happens, and try and clean the data that way. So yeah, so that's what the tolerance is all about. Everyone up to speed with everything so far? Yeah, I see the question there, Ryan, that says the area builder doesn't have a tolerance of its own, and that's totally what I'm going to talk to our developers about, because I think it should have that capability.
Well, it's had the snapping capability for a few years now.
Right.
But it's not quite the same.
No, because it's got endpoint snapping and vertex snapping, whereas if you just look at the snapper, that's got segment snapping, and that's really what we want. And when you do segment snapping, then you can use automatic tolerance. So the area builder doesn't have that segment snapping. So I think that's where I need to talk to, one of us needs to talk to the developer and say, hey, could we get that in there, please? So so yes, there is some snapping, but I think it needs better than that. I think it needs that full intersection, and so we should ask about that one. But yeah, any other questions, just please fire them in. For me, that really is a big thing, because I don't know if you saw the demo I did in the deep dive. I got two data sets. One was MapInfo, one was AutoCAD, and I brought them together, and they should have matched. When I wrote them out, they were the same data set, but they didn't match because those two formats store data in slightly different ways, and you get like this little error of 0.000000001, and it's really, it's not a data issue. It's a problem with storage of coordinates on a computer. That's just how things work, with floating point to integer conversions and stuff. So the automatic thing will solve a lot of those problems automatically. I think you might remember, Ryan, we had a lot of exercises in the past use the coordinate rounder in them.
Yes.
And I don't think we need to do that anymore. The coordinate rounder is basically replaced by this.
So.
Yes, yeah. So if you've got automatic tolerance, you shouldn't really need a coordinate rounder, I don't think, or not as much. So that's what I'm hoping. Okay, 2 more things to do. We've got Microsoft formats and transformers and the FeatureJoiner, not the FeatureJoiner, yeah, FeatureJoiner. So we're going to look at Microsoft formats first. We've got plenty of time here, so let's have a look at these. You might have used these before for Excel, which we already had a reader and writer for. Now we've got a writer for Word and a writer for PowerPoint as well. We don't have readers for those. We've got new styler transformers. We have a PowerPoint styler, an MS Word styler, and an Excel styler. The Excel styler is new as well. So that's good. So that's new for Excel. I suspect if anybody's used, probably quite a few of you might have used it for Excel, and you'll be sitting there thinking, well, what am I going to use it for Word or PowerPoint and stuff like that? That's just not realistic. To be honest, I thought the same thing. I thought, like, why on earth would I like write PowerPoint? That's just like, it ain't going to happen. But I started trying it out, and I'm like, okay, this is actually pretty good. I was like shocked at what I could do very quickly with the power of it as well. So don't close your minds to any of this yet. Just think about this one. Microsoft Word. So yeah, so we've got a Microsoft Word writer, lets you write to Microsoft Word, obviously. We have the new styler transformer, MS Word styler. So what does the MS Word styler let you style? What does it let you create? Well, really, I guess you're writing reports to your Word document. And I know there was a demo of this at the last user conference in Vancouver last year, where someone had set their own tools up to write reports to Word. So what we can do now is we can write that straight out to Word. Now, I think when you write to Word, write to PowerPoint, you have to style the data first. I've tried writing the data just straight away and it didn't like it. So you pretty much have to style it all the time, I think. So we can put a heading in a Word document, so like the title of document or whatever the title is, I can put it there. I can specify what sort of heading it is, what level it's at. We can put images in there. So we can put an image in there, whether it comes from a file or from the feature itself. So I could read a whole bunch of raster features and write them out to a Word document as images. We can create a list. So you say, hey, I want to put a bunch of text in there that's a list within Word. I put page breaks and paragraphs and tables and all sorts of things like that I can construct in Word. So yeah, really, I think a lot of this comes down to being able to order the features in the right order. If we look in the manual, for example, I've got this say table that I'm writing, and I'm writing some data from roads. So I'm writing a list of roads, whether it's a one-way street, what block number it is, that sort of thing, and basically creating a table in Word. We can't write a map directly to Microsoft Word. We can to PowerPoint, but not Word for some reason. I don't think it's got the same API capabilities. So what you can do when you're writing to Word, if you want to put some map data in, like you want to put these parcel lines into your Word document, you would put a rasterizer in there. Whether it's an image rasterizer or a mapnik rasterizer with the extra options, it doesn't really matter. But you would rasterize that image, and then you would connect it to your Word styler, and you would say, I'm writing an image that's coming from the feature rather than a file, like that. And that will give you an image of the data there. Now, when you're constructing a report, for example, a lot of it's going to come down to the order that features arrive in. So that's something you're going to have to control. For example, I can see that you would say, well, I want to write an image, this raster image. I want to write a heading first, then I want to write the image, then I want to do a page break, and then the next one, another heading, another image, another page break. So I think what you need to do there is sort of create a whole bunch of features and sort of order the way they appear. For example, I could put a creator down, an MS Word styler. So I could say, well, look, I know I've got 10 features coming in, so I'm going to create 10 of these features here. I'm going to make that the heading. So that's going to be my heading. And then I'm going to do the same thing again, but this time I'm going to create page breaks. And then I've got my 10 features coming through here, and I'm going to write them all out to Word. Before I do that, I'm going to put some sort of sorter on there, and I'm going to sort my data by some sort of ID. For example, I could put a counter here, and if I call it creation instance, which is what the number is for my creator, that could be like my image or whatever it is, like so. And then in the sorter, I just say sort by creation instance, numeric, ascending or descending, and that should give me heading, image, page break, heading, image, page break. So a lot of the work I think around this is going to be around making sure you get features in the right order to write a report. And when I do that and run it and write it to Word, I should get a separate page for every image that's coming through and sort of create a report that way. PowerPoint. Well, PowerPoint lets you write to a PowerPoint presentation. You can pick a template to use, which is good, and we're going to do that in the exercise in a moment. Basically, you get a separate slide for each feature. So every feature that comes through here, like I've got 79 area features, if I put a PowerPoint styler and basically write them out to PowerPoint, I will get 79 slides because I've got 79 area features and whatever. So I can, again, like Word, you've got all these different options of different slides you can make. We can make a title, an image, a chart, custom, table, but we also get this option to make a map slide with a PowerPoint, which is fantastic because you can say, well, this can be the title of the slide, and we can choose to put a label or not. Whether we want a label in there, we can choose whether to have a fill pattern or a color. So I can choose a color here to write to. I think I've lost a dialogue somewhere. Okay. I think I opened the dialogue up and I can't see it. And I think it must be hidden somewhere. Okay, well, that's not useful, is it? There we go, Ryan's found it. That's the problem with having two monitors. I think that's it. I just got to try and drag it across. Okay, I'm just going to hit cancel and get rid of it. Okay, that's the problem with having two monitors. One appears on the other monitor, and I lost it. But anyway, so yeah, I can set a color, fill color, overlap color, override color for the labels, all sorts of things like that. And I also choose to group features. So I can say, well, I can have a separate slide for every area, or if I've got an attribute, I could store them all on the same slide for everyone that's got the same attribute. Like if it was a block ID for the for those buildings, I could say group by block ID and get each block of buildings separately. So we can do all sorts of things like that with that PowerPoint styler, and having the map option there makes it really quite powerful. So you can do sort of similar things to the Word. You can generate sort of a report or a presentation automatically, like so. The other thing, unlike Word, is that the PowerPoint styler has an option to control the order of features. So you can say, oh, actually, the slide order should be this, and you can pick an attribute that represents the order of the slides. So you've got two sorts of orders going on when you write to PowerPoint. You've got the orders of the features written into the slide and the order of the slide. So if you're writing, say, 5 different features onto a slide, the order that the features arrive in affects the order that they appear on that slide, which one appears above the other. So if you've got an image and then a map, you might want to make sure the image comes first to be underneath the map. So that's how that works, just like Word. But unlike Word, you get the slide order option as well. So you can say, well, this slide comes first, this one comes second, and so on. And we will find that out when we do the exercise very shortly. And yeah, I really like the map slide because it gives you so much capability. You can put a little report in there using this, when I say map slide, you get the sub option of map with caption, and we can fill in a caption here that can be a combination of attributes and user input and all sorts of things like that we can add. So that is really quite powerful. And again, I know you wouldn't think FME writing to PowerPoint, why would I do that? Actually, it's more useful than you think, and we'll find that out shortly. The Excel, well, we already had an Excel reader and writer that you should be aware of. That's fine. Excel styler is new. Again, it's very similar to the other stylers. This time you can apply a style to an individual cell. So you can say, I actually want to style a certain cell or certain attribute. So I guess when it says cell, it must mean sort of the column, I guess. You say, well, the column, we're going to have an FME base name column, so style that to be a different font, a different background color, and so on. I've lost my dialogue again, so I'm just going to try and move stuff around on my other screen so I can drag this back on. There we go. So I can say, well, let's set a color for the background of that cell and a pattern as well, like hatched or whatever. And I can set a cell border and so on and so forth. So the styler actually is applying things that were added new to 2018 in a writer, because before you couldn't create styles like this in your Excel writer. Now you can. And what's more, we've got the Excel styler to let you do that. So if you really wanted, you could manually set a whole bunch of attributes to style your output, but it's way easier just to use the Excel styler transformer. So text alignment, cell protection, is it hidden or is it locked, and so on and so forth. So lots of things there that you can do with the Excel styler. All right, yes, so the Excel styler can do per cell, or it can be for the entire row. So the whole row would be a certain style, just like the example we've got in the training manual there. And in fact, that's interesting because what we've done is we've done a sort of a group by. We said every street name gets its own different color, and I'll show you how we did that shortly because we don't have that option in here. So I'm going to show you that and how that was created when we get onto the exercise. And in fact, we're on the exercise. Okay, so let's get on to Workbench. We seem to be going pretty fast today, so that's good. We've still got an hour to go. So any other questions that we should know about, Ryan? Or is there a way to symbolize the Excel header row only? I think what you would do there is you would say, put a sampler down, assuming your first row is the header, and I admit it might not be. You could say, let's sample the first feature out of here and style it, and then bring it back together afterwards. So if the first row was the header row, then you could sort of pick it off and style it like that separately. If you were wanting the Excel writer to generate the header row, I don't know if there's a style option for that or not. Oops. So we want Excel writer, don't we? Not. So the Excel writer lets you specify, do I output field names, yes or no, but it doesn't let you style that on there. So I don't know. We'd have to check that, and maybe that's a question to ask the developers. what happens to that and whether you could style it. If you didn't use that, I mean, I guess you could always generate your own thing here by sort of making up attributes with the column names in and styling them, and then just saying, don't write the headers out on output. So you could do that. That would.
There's also the templates.
Yes, that's right, the template as well. You might be able to set it in the template if just the header row. But that's a great question. We should ask the developers about that one. In fact, I've got a whole list of things I'm going to ask them while I'm in town. They're not going to like me. They'll be glad to see the back of me after this and next week. Let's put it that way.
There's another good question. Can we freeze the top row in Excel? I guess it's like when you.
Can we freeze the top row?
It's more of a
Well, see, with the styler, yes, we can freeze. We can lock a row.
That should be.
But again, the header row doesn't. I think we might have to add some options to the writer to say, well, if you're writing a header row, this is the style you want it written in, because otherwise that doesn't make sense. To be honest, I don't know if locked means locked as in frozen or locked as in you can't edit it. I'm not sure what it means by that, so I'd have to check into that as well. But that is another good question there that we'll have to find an answer for. Okay, so let's get on to the exercise. What we're going to do here is we're going to start with a blank workspace. And hey, we've been invited to a conference on community mapping, and we are going to provide a presentation on the different aspects of community in the city of Vancouver. So we are going to show a whole bunch of slides about what community means to the city of Vancouver. So what we're going to do is like, hey, we could use FME. We could put some maps in there and show all of our libraries, all of our parks. They could all be different slides. That'd be fantastic. And FME will do that automatically for me. So, well, okay, let's give that a try then. Okay, so we're starting at Workbench and we're generating this workspace as follows. So we'll go into the start and hit generate, or press Control G, Command G, whatever it is. And we will use the API. In fact, actually, just give me a second, because I want to go back to my remote desktop, because I've actually got, let's see if I can get back to that remote desktop. Okay, I think that was a licensing issue that was causing me grief there. The reason I want to come back to the remote desktop is because I've actually got the PowerPoint viewer on here, and I don't have it on my Mac, so that's just why I'm switching over. So Vancouver Community Project. The other thing I'll show you, by the way, that's new for FME 2018 is the training manuals now have little collapsible sections in the menu, which is new for 2018, and I'm very happy for it. Okay, that's besides the point really, but okay, so I'm going to generate this workspace, and we are going to go from API. Yeah, I wonder if our license server went down locally. Maybe that's why I couldn't start it before, because my Mac version is licensed directly on the machine, but this is only licensed on our license server at work. So that could have been the problem there. Anyway, so there we go. I'm reading the community map. I'm going to click the parameters button, and on the table list, I'm going to say just convert libraries. So we're clicking that button there. Okay, and okay. So we're going to read from the community map data set. We're going to read the libraries table. We're going to create a map of libraries, and we are going to write that out to PowerPoint. And we are going to browse for the output, which is going to be output folder, and we are calling it Vancouver Community. I think we've got 3 M's in community, but that's okay. That's how strong a community we are. We've got 3 M's in there. Okay, template. So I want to browse to the parameters and pick a template. What can we do with a template? Well, a template in PowerPoint lets you do things like set the background, set the font. If you've used PowerPoint before, you know you can sort of view the master slide and set things up in there. And that's what I did in this case. So this PowerPoint thing should come under Resources, Desktop Basic, Vancouver template. And there are no slides in that template. All there is the master slide that's set up in a certain style and with a certain background. Excuse me. So click OK, and we've got this. Now, I think if we ran this at this point, it might fail. Whether it would crash or whether it would just write nothing, I'm not quite sure, but that's okay. We are going to actually give it a style. So I'm going to put a PowerPoint styler transformer down, like so. I'm going to open that up, and it's going to be a map slide. And I'm going to use map with caption as a subtype. Okay, so we can put a title down, Vancouver Libraries. For the caption, I'm going to put a fixed value, but really we don't have to. We could open that up and we could sort of create something from the FME attributes and publish parameters and things like that. So we're not limited there to fixed values. We can put any sort of value in there that we like. But I'm just going to put a map of libraries in the city of Vancouver, or something like that, whatever you want to put. If you watch the deep dive webinar that I was involved in, we did a demonstration where we created a separate slide for every park, and so we filled values in here with information about each park, whereas here we're going with a fixed value. Okay, so do we want a library? So, do we want a label on our libraries? So for every library I've got, do we want a label? Well, yeah, let's put the library name down. So we click down, drop down, we'll pick library name. So we're going to create a map in PowerPoint. All the libraries are going to be listed on it, and we're going to show their library name as a label. And we can set the font to whatever we like. I mean, I'm setting it to sort of Arial or to Home, or something basic, I guess I'm using. And I'm just making it a little bit smaller because I'm not sure yet quite what the spread of libraries is going to be. And if I make the labels too big, they'll overlap. So we're going to just do that. Override color. Yeah, I'm just going to make sure they're sort of a dark black so we can see them. And do we want to wrap the label text, yes or no? I'm going to say no. Wrap label text basically means if the label is wider than the object that it's displaying, do you want to wrap the text so it doesn't go any wider? So if I've got like a park that's made up of a square and I've got a long piece of text, do I want the text to be able to expand past that square or just wrap around the shape of that square? So I'm just saying don't wrap it, just let the label across as it is, especially since we're working with point features here. If we're working with point features, that will be pretty bad to try and wrap everything to it. Okay, so I don't think we need to do parameters. We could do a hyperlink. I don't think it says in, oh yeah, also has a parameter for hyperlink. If you like, set the hyperlink to the library URL. So let's do that. I'm going to click the drop down, attribute value, library URL. So for every library that goes into the map, it's going to get a hyperlink to that page on the City of Vancouver's website. And we're not going to have, let me see, what are we going to do? All right, okay, yeah. So for now, we're going to leave the create slide from a single feature. Later, we'll change it, but you'll see that as we get there. Okay, so we've got a point feature. Well, it's not going to show up very well in a PowerPoint slide. I think we're working on improving it to make it a little bit bigger, but for now, it just won't work. So what we're going to do is we're going to turn the libraries into something a little bit larger. And we're going to do that with a 2D ellipse replacer. Basically, that replaces the feature, whatever it is, with a circular feature or ellipse. And if I look in the settings in there, I can set the size of the feature that I want. So we could say it's going to be 200 high and 200 units wide as well. And again, the units, somebody asked us before, the units are whatever units you're using in your source data's coordinate system. So if your coordinate system is in meters, this is meters. If your source data was in feet, this would be feet. So we click OK, turn on feature caching, which it already is, and hit the run button. And let's see what we get out of here. So if I look for the output, I've got the PowerPoint viewer installed, so I should be able to open that up. And we have a map. Well, okay, we've got lots of slides, one for each library. And it's just like a circle. Well, what else, I guess, did we expect? So what we really need to do is we need to be able to group everything together on the same slide. Now, if I look in the PowerPoint styler, I can say multiple features, but then it makes me pick an attribute. And I don't really have an attribute that I can use. So I'm going to have to create something. So place an attribute creator transformer. It says place it between the ellipse creator and the PowerPoint styler. This is important. We did put it here, as we'll see shortly. So we put an attribute creator transformer here. And I'm just going to create a new attribute called group. And I'm going to give it a fixed value of 1. So everything that's got number 1 is going to go onto the same slide. So now in the PowerPoint styler, go into here, create slide from multiple features, and pick that attribute I've created, like so. And all it's going to mean is that everything goes onto the same slide because everything's got the same group ID. That's fine. That's not a problem. Rerun the workspace. Now, if you haven't closed the PowerPoint, you probably should close it because we don't seem to like writing to the same PowerPoint that's already open in Microsoft. So there we go. We've got a single slide with all of the libraries in there on a map. And in fact, we should be able to hover over that and click on it, and it should be a URL, but that didn't work. Maybe that's just a PowerPoint viewer. The PowerPoint viewer apparently has been deprecated from April, so they're not putting any maintenance in, and that could be a reason. We should be getting a URL and hyperlink that we could click on. But anyway, so the map's correct. It needs a background to the library features because at the moment we've got sort of the background slide, but we don't see the outline of the city of Vancouver. We don't know, like it's not really a map because we can't put those in any sort of spatial configuration, like relationship. We don't see it. We've got the background image. Great, that came from the template, by the way. That was already set in the template. So we've got the background image, but we don't have any sort of map to put those libraries in perspective. So we're going to add an extra data set to do that. So I'm going to add a new reader. So we're clicking readers, add reader, and the format is shapefile. And we're going to browse for this data set, which is called, it's in the data folder, boundaries, land boundary, and it's called Vancouver land boundary.shp. So we've got a shape data set there. I know some people really like shape and other people really hate shape, but it gets used so much that we really can't ignore it. I'm going to put it inside this bookmark just by expanding that bookmark a little bit, like so, and connect it up to the attribute creator like that. Now that's why we put the attribute creator between the ellipse and the PowerPoint styler, because we want the land boundary data to get the group and be styled, but we didn't want it to have to go through the ellipse replacer as well. So, I mean, in the real world, you probably would have got that the wrong way around, found that out, and had to switch it back. That's okay. We're in an exercise. We can just pretend we knew what we were doing in advance. So, Okay, so we could run this now, and we could check what that looks like, and we can see the output. Now, I noticed that as soon as we put the land boundary in there, it takes a lot longer to write that data. I'm guessing it's because there's so many points in that land boundary. So I guess what we could do is we could put a generalizer transformer down. This isn't in the exercise, by the way. I'm just sort of thinking this out loud as I go along. We could put a generalizer in there and try and generalize that data to give it fewer points, and then it might write a little bit quicker. So I mean, I'm guessing that we just, I guess writing PowerPoints just has quite a high overhead for map data. So we don't really want to have too much map data being sent to it. In this case, I'll just let it run. It should only be a minute or so, I think, at most. Okay, any other questions? Somebody says, oh, Ryan answered, yes, we can freeze the top row in the Excel spreadsheet. So that's, we can, excellent.
Also, I just got this note here. You don't need an attribute creator for the slide group ID. You can just type in an arbitrary
Right,
string.
you can type in an arbitrary string, that's true. But in this exercise, well, yes, okay. Let's say that's true. You can just type in an arbitrary string into, is that slide ordering or? Oh, for the slide group ID. Oh yeah, there you go. See, you can just type a number directly in there. Well, who knew? Certainly not me. So I knew that we could put a number directly in the slide ordering, but I didn't know the group ID could get a number like that. So that's, there you go. Thank you for finding that out, Ryan. Wow.
For us.
So I guess you're listening into the training there. So we've got the developer listening into the training. That's great. Okay, so let's see, what was I doing there? So yeah, so I ran that data and I wrote the output. And if we look at that output, how are we doing? Well, actually not too great, because the background is over the top of all of the libraries and we can't see the library for the background. So in other words, we've got an issue there where we need to sort that data into a way. Now, how are we going to do that? How are we going to sort some data? Well, we're sort of going to cheat a little bit. We're going to use an attribute called FME feature type, which tells us what layer it came from. And then we're just going to say, well, L for libraries comes before V for Vancouver, so we'll sort it in the right order so that it comes out right. Should we keep the generalizer? I'm going to keep the generalizer in there, see if it makes a difference for me. Let's see, so where are we putting the sorter? We are putting the sorter. Okay, so first thing we do is we open the parameters for the reader feature type. We click on the Format Attributes tab and we say, tell me what layer the libraries are coming from. Now that attribute's always there, we just need to expose it to make use of it. So we only need to expose it in one of them. It automatically appears in the other one. It's because we're joining it together, it'll automatically be there. We're going to put a sorter transformer before the PowerPoint styler and open that up. And I'm going to say sort by FME feature type. It's alphabetic and it needs to be descending, which basically means Vancouver land boundary is going to go first, and that's going to get written first, and then libraries will come after. They'll get written after, then they'll appear on top. So we're good. So we can run that and check the output. See, I guess, oh, it generalized it pretty quick. So, oh wow, that wrote it really quick that way. So yeah, maybe put a generalizer transformer in there and just generalize that output. I guess I should see what it looks like first. It might look really bad or it might look better. There we go. So now we've got the background and we have the libraries on top. So that was the order of features within the slide. It wasn't the order of the slides, it was the order of features within the slide, and that's handled by the order that they arrive at the writer, like so. Now, what else are we going to do? Well, the map was visible, but each library got a different color, and it would be nice if we could change that color. Now, one of the things I could do here is this. I could go into the PowerPoint styler, and I could say, set a foreground or a background. Oh, that's the label, sorry. Oh, there we go, fill parameters. Set a foreground color for the features, and that would work. The problem with doing that is it would give me the same color for the land boundary. So I guess I've got two choices there. I could say, well, I could create a separate PowerPoint styler for the land boundary and then join it together, or I could give them a different color to start with, and that's what I'm going to do. So what I'm going to do now is put a feature color setter transformer down, and I'm going to put it before the sorter, and the feature color setter transformer sets the color of objects, but it's got a randomizing option and it's got a group by option as well. See, that's the problem with the PowerPoint styler. It lets me set the color, but it doesn't let me do a group by as such. I guess it does an attribute value, we could do that, but it doesn't let me randomly colorize things. So I'm putting a feature color setter down. I'm going to say color it randomly, color it based on an attribute, and randomize using the FME feature type attribute, which we already exposed. In other words, give all the libraries one color, give all the land boundary another color. I don't care what color it is, make it up yourself, randomize it, but do that. And I've noticed that this works. It's like having a group by on color, and it also worked really well with the Excel styler. If I wanted to write to Excel, you might have noticed that previously I had that spreadsheet where every row got its own color for each row. How did I do that? Well, I did that using this technique. I said randomly give each feature a color grouping by the road name, so all of the rows got the same color in the output. So okay, so I've set that. All I need to do now is go back into PowerPoint styler and say set the fill color. Foreground color is set to FME fill color. In other words, set it to the same color that I've just randomly created. I know that's a bit of a sort of workaround. It's not as simple as just using the styler transformer, but it is a good way because it's, how can I put this? It is scalable. If I add some more data in here and send it through the same PowerPoint styler, it's scalable. I don't have to put an extra PowerPoint feature. So if I run that and look at the output, now I should find that, hey, we've got the land color is one, the libraries are another color, and all of the libraries have got the same color. Now, you might have noticed, by the way, that there's two libraries in that central location. There's central library and accessible services. They're overlapping each other. We could sort of do something about that, I guess, but I'm not going to worry too much about it right now. I'm just more worried about the color in general, and so on. And the bit I mentioned about with the label and what's the word I'm looking for? Wrapping, that's it. Did I want to wrap the label text, yes or no? If I said yes, then the label would be wrapped so it goes no wider than the object. So it would sort of say Joe Fortes in like 3 lines probably. Accessible services will be a lot longer. So I just wanted the label as long as it could be, so I said not to wrap that data. Okay, we could do with a title slide, that's for sure. So what I'm going to do, quick title slide, I'm just going to put a creator transformer down, because I don't want to create it from features. I just want to create a title slide. So I put a creator down, PowerPoint styler transformer, open that up and say, hey, this is a title slide. The title is Vancouver Communities or Vancouver Community Info or something like that. Doesn't really matter. And the subtitle is going to be a series of FME generated maps and charts, because we could do charts as well. And the slide ordering, this is going to be important. We want this to be the first slide to be written, so I'm going to change the order to 1. And that'll be the first to be written. Now, I can just connect that up, and that'll be okay, except we need to say that the libraries are going into slide number 2. So we go into here, look at the slide order at the bottom. Number 2 it is. Okay, that. And I think we are good. We could just run that. And now we should have 2 slides. We should have the title and we should have parks as well. I think really as well that generalizer is a huge thing to put in there, because the more data you have, the longer this takes to write. I think writing to PowerPoint is fairly slow when it comes to map data. So if you can take vertices out of that map data, hugely faster. Here we are, we got our title slide now, and it's first. Importantly, it's first. Click the next button, there's our libraries, hey, and that was it. Now, of course, we could take that even further. We could say, well, let's add some parks data, and we could sort of throw the parks data in there and make that another slide. I'm not going to do that. I'm just sort of adding this as a sort of demo. So we say, okay, add the parks data. In fact, maybe I should show this to the parks just because it's so interesting. We're going to put a PowerPoint styler down. It's going to be a map with title, Vancouver Parks. Actually, it's going to be map with caption. I'm going to give each park or each neighborhood its own different set of info. So if I could say like parks, actually no, we could put a caption there. I'm not going to bother now. Again, I'm sort of off-roading here just to show a few different options. The label, we're going to use the neighborhood name as the label. We don't want to wrap it. Do we want the neighborhood name or do we want the park name? Park name, I think. Okay, Vancouver Parks. The caption can be the neighborhood name. That's good. We could set the fill parameters, so the foreground color, the parks are going to be green. We're going to create a slide for multiple features, but instead of putting everything on the same slide, I'm going to group by neighborhood name. And slide ordering is going to be 3. I'm not sure what's going to happen there because we're going to generate multiple slides. I assume it's going to start at 3. Oh, I guess perhaps it doesn't mean the slide number. It just means the order in which things get written. So I was confusing that number there with the slide number, and I don't think it's the same thing. It really isn't. So if this is generating slides 3, 4, 5, 6, 7, 8, that's a slide order. It's not a slide number. Okay, let me just take a quick look at that. Here's our header. There's our libraries. There's Vancouver Parks for the Kitsilano neighborhood, for the Mount Pleasant neighborhood. So remember, I did a group by neighborhood. That's what we're getting here. We're getting a different slide for every neighborhood of parks. So Strathcona, West End, Fairview, downtown, and that's it. So we can start putting together really big things here for PowerPoint presentations. The other thing I wanted to just sort of mention is the ellipse replacer. Although this doesn't really have anything to do with PowerPoint specifically, we could say instead of putting 200, we could say the primary access is the book count. So each library will be bigger or smaller depending on how many books it's got in it. You can do things like that as well. I'm not going to do that now, but I'm just going to mention that that's a possibility. Okay, everyone up to speed on that? I mean, again, I know PowerPoint to me doesn't seem like like I wouldn't have thought to use it, but as soon as I started using it and found I could do things like that with the background and different parks and different slides and stuff like that, I'm like, wow, I could actually make real good use of this. So I'm very impressed with that. And of course, the Excel styler, you might use more, works pretty much the same way as the PowerPoint styler in terms of styling things as well. And so does the Word styler and writer. Okay, last chapter today. Last thing you need to know about when we're upgrading to 2018 is this FeatureJoiner transformer. Why is that important? Well, we already had a feature merger transformer. Now we've got this FeatureJoiner instead. Excuse me a second. Okay, so why do we need to know about this? Well, because you probably got used to using the feature merger, and now this transformer comes along and you need to know about it and you need to know how it works. So let's have a look at that. So the FeatureJoiner looks like this. You've got a left and a right. So compare it to the feature merger, for example. The feature merger had a requester and a supplier, and sort of implied in that is the requester data is requesting information from the supplier, and anything that counts as a merge is basically the requester with extra info. With the FeatureJoiner, it's not the same. It's left and right, but neither of them is really the master in the same way. Like here, you could say the requester is the master feature that's getting information joined on it. In the left, with left-right, neither of them are the master. It's like, well, whatever joins between the two, you will get an output feature, whether it's the left joins to the right or the right joins to the left, whichever way you look at it, you are going to get that data out of the joined port. So let's have a look at that. I'm just going to connect this data up. I don't think we've got anything that's going to match as a real join. This is just to show you what the dialog looks like. So the dialog looks like this. We have the join type, the mode, and we have information about how to resolve conflicts, which is interesting, but not vitally important for us here today. And then we get the join attribute. So which attribute do you want to join on? So I could just sort of pick a couple of attributes and they'll join together. The comparison mode, again, automatic, string, or numeric, depending on what your data looks like. So, I mean, the join bit there is very similar to the feature merger, and the conflict resolution is similar to the feature merger. The big difference there is the mode. So what is the difference between inner mode, left mode, and full mode? Well, what we tried to do is try to make this similar to SQL. It's all based on sort of a SQL statement, if you like. And if you've used databases and SQL in that, you'll know that you can have inner joins, outer joins, left joins, right joins, full joins. And so that's really what we're doing here. And if you look in the training manual, we've got a table in there with a whole bunch of different diagrams to show you what they mean. So a left join basically means all of the left features look for a match and they are output whether they have a match or not. So in this case, any features from the Vancouver land boundary come in, and if it's a left join, they will be coming out of the joined port whether they had a join or not. That's what a left join is. Left, but really when we talk about the mode, what we're talking about is not what's getting joined, but what happens to the features that aren't joined. So here we're saying, well, if it's a left join, basically all of the left features come through here regardless of whether they've been joined or not out of that port. So that's sort of like the feature merger merged port. If we change the mode to inner, we say, okay, now the left features only come out of there if they did actually find a join. If they didn't find a join, then they'll come out of the unjoined left. But if we're in left mode, basically, even if it doesn't find a match, it still comes out of the joined port. But in inner mode, and you can see the Venn diagram thing in the manual, which shows that if the left and the right overlap, there is a match, then that match comes out of the joined port there. And if we go into here and say full join, that means basically anything that joins comes out of the joined port. The left, the right, everything. There's nothing unjoined. Everything is a join because it's a full join. Now it might not have all of the attributes from the other features because it didn't actually find a matching feature. But if you're in full mode, then it still counts as a join and it still gets output. That's why it's more like SQL than the feature merger was. If the feature merger didn't find a matching feature, it would come out of unmerged requester. It would always come out of that. Whereas here, it might come out of the unjoined left, it might come out of the joined. It totally depends what mode you're in. So you need to sort of be up a bit on the different SQL modes there. And you might be wondering, you say, well, left join in there, but you don't have right join. How can we do a right join? Well, a right join is just a left join, but you switch the two inputs around to different ports. That's all a right join is. So like that. Now that's fairly straightforward because you say, well, okay, say we've got a one-to-one match, that's fine. But what happens if we have more than one match? Let me see if I can put an actual demo together to show this. So I'm going to add some parks data. So there's my parks. I'm going to add some KML data with neighborhoods. So data, boundaries, Vancouver neighborhoods, and we want the neighborhoods layer. So what I've got here is I've got a parks layer and a neighborhoods layer. And for example, the parks have got all of this information and the neighborhoods have got that. And the park has a neighborhood name in there, and obviously the neighborhood name has a neighborhood name. So we could say, let's put a feature joiner down and create a join between the parks and the neighborhood information. And the join is going to be on neighborhood name, and we are going to call this a left join. So in other words, even if we've got a park that doesn't have a neighborhood, we still want it to come through the join port. Okay, we seem to have something rejected, so I'm just going to put a logger on there and run that again. I'm not sure why it was rejected. Okay, so we've got 80 parks features there, and probably rejected because I said it was a left join and I didn't want the right features. So all of the right features will come out of there. So yeah, so we've got 80 parks and they all matched up to a neighborhood name, and now we should have that information on there from that neighborhood, from the match. Like so. So the thing is though, what happens if we've got multiple matches? So for example, we could say that, well, each neighborhood is a feature as well. So if I change this to full join, what do I get? I think I might get more than 8. See, I only got 6 joins there because only 6 features joined together, I guess. We only have 6 unique joins come through because neighborhoods is there. So we only got 6 full joins there. We're not keeping the left-hand features that didn't match. So really we've got this idea of sort of, well, what counts as a multiple join? Because in the feature merger, you used to have this option that says, do you want to process multiple suppliers? It used to say process duplicate suppliers. We don't do that now. So if we said, well, the neighborhoods are coming in here and we're matching it to a park and there's actually multiple parks per neighborhood, what do we want to do? We don't have that option to say have multiple features, handle multiple ones. It just outputs all of the matches that it finds. So for example, here we've got 6 input neighborhoods, 80 parks match, so we get 80 features coming out. Whereas in a feature merger, if I did the same thing, we'd only have 6 merged features coming out because it ignores the duplicate suppliers by default. So we've got to look at the fact that we get multiple joins, make multiple features. We don't necessarily get one feature per input record. If we had 100 neighborhoods and some of them were duplicate records, we get multiple features out for them. It's creating a feature per match. And that's what I think I might be explaining this fairly badly here because I'm stumbling over my words a little bit. I can tell I'm not explaining it very well. Have a look at the page in the training manual about multiple join matches. It will make a lot more sense there, I think. It says, well, look, if you've got this data coming in that screenshot, what features do you get out? If we had 2 matches per feature, then you would get 2 outputs for it. So yeah, so have a read of that if I've not explained it very well. Meanwhile, let's go on to the exercise. We've got about 20 minutes left to finish off, so we will do an exercise. We have a starting workspace here, and it's in FME Data 2018. Workspace is upgrading, and it is called FeatureJoiner Exercise 1 Begin. So what we've got here is an exercise. If you've taken the basic training course, you might recognize this little bit of workspace. We're trying to join postal addresses to crime data, so we find out how much crime appears per address. And this little few transformers there are basically cleaning up the address data, so we've got a proper join key for the crime data. So, oh, the other thing I should note, by the way, is the crime data is being read directly from the City of Vancouver website, ftp.vancouver.ca/open-data-crime. This is a great example where you want to cache your data when you've read it, because you don't want to be reading that every time. And if you can't for some reason read from that website directly, we do have the data set on there. If you look under data emergency, and it's a zip file, crime all years, so you could change to that if you wanted to. Okay, so before we do anything else, we're going to put the caching on. We're going to run the workspace and read the data. Oops, I pressed the wrong one. There we go. Run the data, run the workspace. And we're reading the data and we're caching that data. So again, another good example of caching data. We've read it from the City of Vancouver website and we have cached it, and we don't have to read it from there again. So that's a great example. Now, the other thing that's different between FME 2017 and the feature merger and 2018 and the feature joiner is the feature merger let you construct keys in there. It had the text edit dialog. The feature joiner doesn't seem to have that. I'm going to have to query our developers about that, because I'm wondering if maybe it should have the ability to open up a text editor for that, but it doesn't. So what we're going to have to do is we can put the feature joiner down, but we can't construct a key in the left and right. We either pick an attribute or you don't. And I think maybe because they wanted to make it simpler, that's why they left that out. But really, that's an important thing to have. So we're going to need to do that. So what we're going to have to do instead is put an attribute manager transformer down. And we're going to put that down in this bookmark, because again, we know this part works. We don't really need to cache everything in there. And we're going to open this up, and we're going to create a new attribute called join key. And in the attribute value, we're going to click on that, open the text editor, and we're going to put that construction in there. And you can construct that by typing it, by picking the string functions from here, or you can either just copy it from the training manual and paste it into there, or we should be able to copy, paste. No, it doesn't like that. Okay, I'm going to have to write it in by hand, or pick the attributes. Let's see, number, space, street, like so. So basically what we're doing is we're constructing a key out of the street number and the street name with a space between them, and we put the trim function around it just to get rid of any extra space characters that might be before or after the record. Okay, now we've got our feature joiner, we can connect that in. So the attribute manager is the left and the crime data is the right, like so. And we open up this and we're going to say, let's use an inner join. In other words, we're only going to keep the addresses where there is a join to crime on the same block. So in the join on option, we're going to select the join key from the left. See what I mean? Normally we could open up a text editor and construct that key directly. Now we can't. So we're going to do that and pick the join key. On here, it's called the 100 block. See, that's the issue there. The crime data is organized by block number and addresses are organized by address number. So we've sort of had to do a little bit of manual preparation on the address to give it the same key that will match the crime data. So we're going to join that data. So we could run that now, and you will find that we get one join per match. So we get 67,000 features out that are joined. Why do we get that? It's because there are a certain number of addresses that found a match to a crime that occurred, and there were multiple crimes that occurred on that block. That's why we're getting all of this, all of those joins, 67,000 joins, because 13,000 addresses matched to an average of 4 crimes per address. So we get 67,000 coming out of there. So that's sort of what I was trying to explain earlier when I was talking about multiple joins, multiple matches, and how you get multiple features out. And the feature merger would not have done that. The feature merger would just output one address record plus a list of crimes. The feature joiner does not do that. So we're going to have to start doing things to sort of work around that, or to handle what it's outputting. Okay, so the reason we want to carry out the join is to assess crime for each address. How are we going to do that? Well, we're going to give a number to each crime that's committed, each type of crime. So we're going to put an attribute value mapper transformer down and connect it to the joined output port. So these are all our joins, and we're going to open that up. And what I want to do is say, well, let's look at the type of crime. So we'll map the type of crime to a crime value. And then what we need to do is list all of the different types of crime down the left and give them some sort of value for the right. So we'll do that. The easiest way of doing that is using this import tool. Again, this is not 2018 specifically, but it's a very useful thing to be aware of. We can click import. The data set is Excel. So in other words, so what I want to do is I want to scan that Excel data set. Let me find it. It's under emergency, but it's a zip file. So you're going to have to change the file extension that it's looking for to a .zip. Pick that. Click next button. It says, okay, you've got all of these spreadsheets in there. Which one do you want to use? And we're just going to use the 2017. So what we're trying to do here is find the list of all the different crimes, types of crime that are listed in the manual, so we can give an assessment to those different crimes. And it's going to take a few seconds to do this. That's okay. I'll just let's see. Okay, there we go. So we're going to say, well, let's just take that slide, import from the attribute values. In other words, don't look at the names of the attribute, look through the crime value and tell me what crimes you've got in there. So we look for the type field. So if you didn't get that, you pick 2017, you say look in the attribute values, look for the type, and just import that. So what that's going to do now is scan that sheet, find all of the different crimes, and put it into there. So again, just take a couple of seconds to do that. I guess there was a lot of crime going on. Interestingly, this is the crime figures for 2017, isn't it? Yeah, I was going to say some of the crime I've looked at before, we used 2011 as the default crime data set, and 2011 was the year that we had the riots downtown because of the hockey tournament. And if you look at the crime numbers 2011, it's like, wow, I would not want to live in that area, when in fact it wasn't really that bad. It's not really that bad. It's just on the occasions that we get to the hockey final that we have the problem. Okay, there we go. We've scanned all that. We're good. So that's our list of our crimes. Let's give each of them a value for how bad we think they are. So say out of 25, that's what I'm going to do. So on a value of 1 to 25, I think homicide is probably a 25. It's about as bad as you can get. Theft of a bicycle, well, I do. I don't know. Some people would say that. I don't think I'd quite go that far. This is a great experiment, by the way. We can find out what you're doing and what values you think they're worth. I'm going to say, I don't know. What does it say in the manual? Theft of bicycle, 5 points. I mean, I'd say homicide is probably 5 times worse than theft of a bicycle. I mean, this probably very much aligns to your. See, I drive, I don't ride so much, so that's like 10 for a vehicle. Pedestrian struck with a fatality, I'm assuming it was an accident, otherwise it would come with a homicide, so we'll say 15. And if you were just injured, we'll say 10. It doesn't really matter what you put in here. Yeah, stealing from commercial property, that's not a crime. Breaking into residential, I'm just making up numbers here. Just please don't ascribe any of this to my political leanings or read anything into it. Theft from a vehicle, 10. That's because I have a rental car outside right now, and I don't want it breaking into because the insurance would hit me. So I'm going to say that's a big one there. So anyway, just fill in some values there, whatever you feel like. It doesn't really matter. You can just put random numbers if you like. So what we're going to do, what we've got now is we've got a whole bunch of matches. So these are all the crimes that we've got that matched, and some of the addresses on the same block. So we've got multiple. So that's a great example of getting more joins out of there than we actually get features going in, because multiple addresses are matching to multiple crimes, and they're matching to the same crimes because they're on the same block. So what do we need to do? We need to aggregate those together. We need to aggregate them by the address, because we're interested in the address. So we're going to open the aggregator up. I'm going to say group by postal address. In other words, each address becomes a group of crimes that happened. And further down here, we have count attribute. I'm going to say number of crimes. So that's going to tell us how many crimes were carried out in the block where this address is. And further down that, we've got attributes to sum. And for that, I'm going to select crime value. So not only do we know how many crimes were happened, we know what the sum of the values are according to our definition. And we click, yeah, we could generate a list as well and create a list of crimes, but we don't really need to do that. So we're going to run that on the aggregator. Again, we're using the caches. We're not having to read all of that source data. We're not having to carry out the join again. That's important because the join was taking us quite a while as well. And the aggregator, we got 4,000 records out. So what's that telling me? Well, we grouped by postal address. So that's telling me that 4,000 addresses had a crime occur on that block. If we add that to the unjoined left, which is the houses that didn't have a crime, it comes out to 13,597. How do I know it comes out to that? That's because that's the total number of addresses. So we've got 9,000 addresses without a crime, 4,000 addresses did have a crime, 67,000 crimes in total, and we've aggregated them together. So now if we looked at that, we would find all of the addresses. We could click on one of these, for example, and we would find out that has a crime value of 745. Yikes, that's pretty crime ridden there. 101 crimes occurred on that block. Again, we could sort this numerically and say, well, the worst number of crimes in any address was 336 happened on that block. Maybe that was 2011 with the hockey riots going on. That certainly seems to be the place it would have occurred. So anyway, so that's that. We could sort by the crime value. So perhaps the one that's got the most crime wasn't the most serious crimes according to us. And yeah, we could sort the data like that. Okay. If we inspect the aggregator, notice each feature is made up of a multi-point. So if I query one of those, you can see it's multi-point, 335 parts. Why is there 335 parts? It's because that's the number of crimes. That's the number of joins we made. We made 335 joins. So when we joined it together, we aggregated all that together and we made an aggregate feature with that many number of points. That's not the joiner doing that, that's the aggregator doing that. Because the aggregator doesn't let us just pick one geometry. It says you've got to assemble your geometry together. So all I'm going to do just to get rid of that is put a center point, replace a transformer down, and say just replace whatever that is with a single point at its center. And I don't think there's even any settings we need to do there. We could run that, and that'll happen fairly quick because again we're only running that little bit. And now when I query something, we only get a single point for that. So what I'm trying to show there is the difference in the feature joiner and why it's new and what different it is to the feature merger. So in this case, it produced 67,000 joined records because, say, one address on a block linked to 200 crimes and another address in that block also linked to 200 crimes. So that's 400 joined features you've got coming out just for 2 addresses. So that's why we're getting more features out of there than came in. So it's something to watch for. Maybe you need that. I mean, it's sort of the equivalent of putting a feature merger down, saying in the feature merger, process duplicate suppliers, and put a list. And the list is list of crimes. So it's sort of like doing that and then following that up with a list exploder. So if we did that and did a list exploder, the number of elements would be 67,896. So really the feature joiner is just sort of doing that together. And sometimes you don't want that list exploding, so we aggregated it back together again. That's what we did there. But we wouldn't have been able to do that attribute mapping unless that was already like that. So if we wanted to do the same with a feature merger, we'd have to explode it, map it, aggregate it back again. So anyway, that really is the key difference. The feature joiner is producing a feature per join, not a feature per input feature. That's the thing to look at it for that. And we finished with 2 minutes 49 seconds to spare. That was pretty good going.
Yeah.
Hopefully you found that really interesting. Hopefully now when you upgrade to 2018, you'll be able to know these are the key things and these are how they work. If you take an existing workspace and upgrade it and bring it into 2018, don't forget to do any upgrades you need, but you should find that the caching will work automatically on that workspace. So we're not really here to look at, can I upgrade my transformers? Like, okay, you can. The key point is that whatever you do in 2018, you're going to need to know about what these pop-up buttons do, what run to this and run from this means. And that's what we've been trying to show this morning is when you open up your workspaces in 2018 or whether you create new workspaces in 2018, what we've looked at today are the key things that really make a difference about what's new in FME 2018. And I think there's some amazing functionality in there. The thing with the partial runs, to me, it's just fantastic. I don't know, I mean, what you think about that, Ryan?
Offering standpoint, it's one of the biggest changes in many years, I'd say.
Yeah. And so one of the ways I look at that is we call it run with feature caching. one of the things I actually just suggested, and we didn't do it, but we could have called that authoring mode or design mode or something like that. Because what you really should do is have that turned on while you're designing your workspace. And then we get to this point, you say, okay, I've got my workspace, it's all correct, I know it's working, I'm going to put it into production, I'm going to turn off run with feature caching. I'm exiting design mode, if you want to put it that way. And now I run the workspace and no caching is going on, and it runs that much faster because of that. So sort of think of it as an authoring mode, a design mode. You turn it on, you generate your workspace, you construct that workspace bit by bit, testing things out, then you turn off the caching when you put it into production.
Or publish it to FME server.
Or publish it to server, yes. Yes, exactly. Which would count as putting it into production in my eyes. Now, the one thing we didn't mention today was something that got dropped from FME 2018 was the ability to have the data inspector inside Workbench. We had this idea that you could view windows and it would be like, oh, visual preview in beta. Well, okay, I've still got it in there. I don't know that it's in there anymore. I think it got removed. But really, that's no different. I mean, if I inspect something here, all it does is it shows me inside this window instead of opening it up in the data inspector. So really, I don't know that that's going to be a huge difference. To me, the more important stuff is the partial runs. The fact that you can or can't inspect it in Workbench, that to me sort of is a secondary issue. Might come out in 2018.1, might be 2019, but that will happen. We will get the data inspector inside there. Any other questions that came through, Ryan, that we should perhaps know about? Not too many. When is the 2018 release date? We don't know. I think there is, well, I know there's one thing that somebody was having a problem with, and we wanted to make sure it worked because it might have affected more users. So I know they were looking at that. Hopefully within the next couple of days, I would think it's going to be coming out. That was certainly the intention, was the start of March. And just this one thing we wanted to make sure was right. Been tricky to track down, but tricky to track down.
I'm confident this month.
Yeah, well, put it this way, it's going to be before next Thursday, I would think, because next Thursday is the first date on the World Tour, and if it's not done by that, then we're really going to be in trouble. So I'm very, very confident it's going to be by next Thursday. Anyway, as always, I just wanted to show a few slides at the end, or a few bits at the end, to cover extra resources out there if you need any more help. Don't forget our website and our support team, safe.com/support. They're really good at helping you out, and if you've got any questions about 2018, they will be able to help you upgrade your transformers and things like that, and use the new functionality. So please do get in touch with them if you need that help, or your local partner. There are partners around the world. You might have purchased FME from a partner. They will be able to help you as well, and maybe in your official language as well of your region, which is even better than listening to me. So waffle away in English that isn't your first language perhaps. So we got a blog, we've got a few items on the blog about 2018. I'll try and put some more out there, but pretty much what I put out there is what we've covered today anyway. So if you've used FME 2018 today, you should know pretty much what I'm going to put on that blog. Don't forget the Knowledge Center, the channel, the Q&A forum, all on knowledge.safe.com.